So as usual, try to stay on the camera to make your, to take your learning to the next level. You can be interactive. So do you know what is our topic today? Topic of discussion, very, very important topic, particularly for the manufacturing related professionals. Even other professionals, if you participate actively, you will learn how to use this tool in your domain, right? All the tools we discuss and all the concepts we talk here, though all of them, originated from manufacturing industries, they're all applicable in non-manufacturing domain as well. So today we are going to talk about process capability indices, CP and CPK. I hope you already had a chance to discuss the same with Dr. RK. So, did you understand anything about the CP/CPK? What is your current state? Can you please speak out? Whatever you know about CP and
Sir,
CPK.
I guess RK sir has given overview only, but well, in one slide he has just touched the topic, but in depth it was not covered in the last session.
Okay, so we'll deep dive, no issues. But what is your understanding right now? CP/CPK means what?
TPE is nothing but the process capability to know where
Hmm,
exactly our process stands, whether it is a stable, whether it is within the control, or whether it is near to mean, or it is having a lot of deviation with respect to its mean. And
super.
CPK is nothing but the indices, the process capability index to check whether with the upper level and the lower level control.
Very good. Good understanding. Excellent. I'll also add my point. There anybody else would like to add no your point about CP and CPK?
Yes,
When
sir.
can we
So this
when, please sir?
yes,
Yeah,
sir. Sir, CP is nothing but potential capability, and whereas CPK is process capability.
very good. Good understanding. Excellent. Okay.
The formula to calculate it is CP is upper specification limit minus lower specification limit by 6 sigma. And CPK is mean upper specification limit minus mean by 3 sigma. Minus.
Yeah. There are formulas. No need to
Yeah.
remember the formulas. Well. Very good. You pointed out.
Sir,
Okay.
CP is how the variants are spreaded with respect to the center point,
Hmm.
and the process capability index, how they are shifted from the how to find we can find process shifted from the center.
Very good. Very good. So excellent understanding, all of you. Round of applause. You even before we could teach in a detailed manner. You all could speak
CPK,
very well.
yes.
Hmm.
Yeah,
Yes, sir. Go
CPK,
ahead, Satish.
is CPK is whether the process is centered within the limit. Actually, CP is
Okay.
process with specification limit. Like that, RK sir teacher actually in the last.
Very good. We'll develop a deeper understanding right now. First of all of you please note CP/CPK is a tool which can help you to measure the process capability or capability of your process if the outcome of the process or the output of the process is measured in a you know is measured in a continuous data format. Which format? Continuous data format. Let's say you produce parts, the diameter should be within the requirement, within the specification. Or you produce parts, the surface finish should be within the specification. Or you are a doctor giving some treatment, and the outcome of the treatment should be sugar level within the specified value. Or it's a chemical process, the outcome should be the material characteristics should be within the specified values. Or you are a banking professionals, you are developing a process, the process should be the turnaround time of the process should be within the specified limits. Or you are processing a loan must be processed within the specified timeline. Do you see in all these example I am pointing out some measurable characteristics? You see some continuous output in the form of continuous data, yes or no?
Yes, sir.
When I say the data is continuous, what does it actually mean? When can you say your data is continuous? Can one of you or few of you answer this question? When can you say your data is continuous?
The data will be taking it without within the frequency, specified standard, continuously monitoring and taking the data.
Okay. Any other answer? When can we say our data type is continuous?
It comes in agreed frequency.
All right. So this is very important. So because CPCPK,
Process is within limit. Actually,
I'll tell you.
if we are having standard process limit.
I'll tell you. CPCPK can be used only when the process output is measured characteristics, meaning the data type is continuous. Continuous data means measurable data. How do I know? After measuring, when you record it, there will be a unit of measurement. Let us say you are measuring thickness, a thickness of 2.5. Do you understand anything from me?
In micron, we
If
can
if I remove the unit of measurement, I only say 2.5, and you are now, lagging in terms of, the completeness, isn't it? 2.5 millimeter, centimeter, 2.5 microns, or it is 2.5, meter or whatever. Some unit of measurement is required to be included while, recording the, what do you call, the
data.
Measurable
size.
data.
Yeah, then only it is called measurable data. Only for such characteristics, CPCPK study is applicable. Clear, all of you? First of all, if you are not dealing with measurable characteristics, not dealing with the continuous data, you don't have to complicate the situation, with the CPCPK. You can simply express your baseline with the help of tools, other tools such as DPMO, PPM, or defects per 100 units, defects per 1000 units, or first pass yield, things like that. But if you, but if you want to use CPCPK, please ensure your data type is continuous data. Is this clear with all of you?
Yes, sir.
Yes.
Continuous data means you can calculate average. You can calculate average. Wherever you cannot calculate average or your average is misleading, in such areas, please understand your data type is not continuous. No? So, and another way of defining is there will be a unit of measurement. I will simplify this subject, just by creating a scenario. Imagine there is a big river, which is, a very deep river. And so a bridge is constructed. A bridge is constructed. And bridge seems to be, narrower only. At a time, maximum only 2 vehicles can go. A bridge is constructed. Now you wanted to cross this river through that bridge. So you need a vehicle, or you come by a vehicle. You come by a vehicle. Let's say your vehicle is car. Now if you want to take your car and cross that river through the bridge, the first important criteria is your car size must be smaller than the width of the bridge. Yes or no, all of you?
Yes, sir.
Can you take a car which is wider than the bridge and then, try to use it? Then you are actually, taking a big risk. This study is known as, this is nothing but, we are checking with the help of the tool called CP. CP is only checking whether your car is smaller than the bridge or bigger than the bridge. Right? Whether your car is smaller than the bridge or bigger than the bridge. If your car is bigger than the bridge, your CP will be, very weaker. Your CP will go below 1. Your CP will be below 1. If your car is smaller than the bridge, then there is a chance you can easily cross the river. Yes or no?
Yes, sir.
There is a chance. That is why we call it, potential process capability ratio. A chance exists. But if your car itself is bigger, chance also doesn't exist. Clear? Even if you are a smart driver, you will still end up in some problems only because your car is bigger than the width of the bridge. I hope this is clear. So CP means you are only checking whether the car size is bigger than the bridge size or not. In business process, there are two things very important. One is tolerance given by the customer. Another one is tolerance consumed by your process. Are you getting it? Tolerance given by the customer. Another one is tolerance consumed by your process. Tolerance given by the customer is nothing but the bridge size. Tolerance consumed by your process is nothing but the car size. Your process should consume the tolerance given by the customer in a way that the consumption is lesser than what has been given. Yes or no?
Yes.
Or you think like this, the salary and then your monthly expense. Can you spend more than your earnings?
No.
Definitely no. Always your monthly expenditure should be smaller compared to your earnings. Similarly, the tolerance consumed by your process should necessarily be smaller than the tolerance given by the customer. This is what we will be checking. And the ratio is called process capability ratio. One of you correctly pointed out, sir, there is a formula. CP equal to USL minus LSL divided by 6 sigma. Why 6 sigma? Because what 6 sigma represents here? USL minus LSL, everybody knows, isn't it?
Yes.
Because USL minus LSL is nothing but
upper and the
a
lowest
tolerance.
Maximum achievable process.
Yes. LSL, USL. This is the customer provided tolerance. The limits are known. And now my process is operating. My process can operate in whatever way. And see here, any process is considered to have a spread of how much? 6 sigma. Why 6 sigma? A session has been arranged to all of you. I think on day number 3 last week, isn't it? We have been taught basic statistics and normal distribution. Have you attended, all of you?
Yes, sir.
According to that, any bell curve will have a spread of how much? 6 sigma. The center will be represented by the mean. What is this vertical line? Upper control limit. And this line, lower control limit. And what will be the distance of this upper control limit from the center? 3 sigma.
Yes.
And similarly, the lower control limit from the center, that is also 3 sigma. And the area below the curve within the control limit will be 99.73%. Have you discussed all these things?
Yes, sir. Yes.
You must understand, you must remember, you must expect these things to happen in real life. That means when you produce 1000 parts, 997 parts must appear inside the control limit. Otherwise, either your process is abnormal or your control limits are wrong. How many of you understand? If you produce 10,000 parts, tell me how many parts should be expected to be inside the control limits?
97.
You produce 10,000 parts.
9,970.
Very good. If you produced 10,000 parts, for sure 9,973 parts must appear inside the control limit. And that is why it is important we should know where is our control limit. Our control limit should appear inside the specification limit. You look here, there is specification limit. And this, what is this line? This is our control limit, isn't it? You must be able to see the control limit inside the specification limit. Simply put, if control limits are seen inside the specification limit, your process is capable. If control limits are seen outside the spec, your process is not capable. Definitely there will be failure, rejection. If control limits are inside the spec, then both CP, CPK will be more than 1. Are you getting my point? When this condition will be satisfied? If control limits are
within the
Within the specification limit.
within the specification limits. Otherwise, CP, CPK will be less than
Right.
1. And now talking specifically about CP, we are only comparing the car size and the bridge size, right? And the car is nothing but your process. The bridge is nothing but the tolerance given by the customer. So USL is given, LSL is given, and your car is also available here. So UCL is given, LCL is given. Now, merely having a car doesn't mean you have safely crossed the bridge. In order to safely cross the bridge, you know what needs to be taken care further? You should not only have a smaller car, you should also have a good driver. Yes or no?
Yes.
Yes.
Unless and until the driver knows how to drive, where to drive, you can't really cross the bridge and reach the destination. If you really want to cross the bridge, probably you must drive through the center of the bridge. Yes or no?
Yes.
Yes.
The bridge is already narrow here, taking towards left or towards right is not really good. It's risky. So you drive through the center, and the center point of USL and LSL is the target in most of the situation in manufacturing. Because manufacturing, most of the time we work with the bilateral tolerance. Yes or no? Customer gives plus or minus 100 plus or minus 0.05. 12 plus or minus 0.05. That means it's a bilateral tolerance. Normally, when you have USL and LSL, the midpoint of USL and LSL is the target. So, the driver should have the ability to drive the car
In the center
through
of the
the targeted point. In order to check whether your driver is driving properly or not, we need another tool known as CPK. So CP is only checking whether the size of the car is smaller than the size of the bridge or not. But CPK, it checks two things. First, it will check whether the car size and bridge size, are relatively correct. We want the car to be smaller. Yes, that is correct. Let me drive. Now I have the excellent driving skill. I can drive the car exactly through the center of the bridge. That means for me, CP is equal to CPK. Do you understand when the CP is equal to CPK? If you have a car and also good driving skill, for you CP will be equal to CPK. If you have a good car but do not have a proper driving skill, you know what will happen? When you drive the car, your car will go like this. Yes or no?
Yes.
But those who have the correct driving skill, they will be able to drive properly, always through the target. And so, some people, might do many mistakes. I'll tell you. If this is the, let's say this is the target, they might, drive on the left side. Some people might drive on the right side. So these are referred as, shift. You are supposed to drive through the target, but then you completely shifted on the right side. And some people completely shifted on the left side. Whether it is a right or left, you have experienced a shift, isn't it? If you come away from the targeted point, and if the bridge is also narrow, then it is riskier, isn't it? If the bridge is wider, then certain amount of shift is okay. But if the bridge is already narrow there, then experiencing shift can be very risky and dangerous as well. All of it, do you understand?
Yes.
Yes.
Right? So you have to do a similar study, similar comparison with respect to your process. You must be knowing the tolerance given by the customer. If customer haven't given any tolerance, you can define the tolerance on behalf of the customer. You can define the tolerance on behalf of the customer. In such a case also, they will be called as what? USL and LSL. And assuming a bilateral situation, the target is at the center. Now your car is replaced by the process, right? And once you have process data, you can visualize your process. Process when visualized, always it will the tendency will be very high to appear in the form of a bell curve. Particularly for continuous data, the tendency to appear in the form of a bell curve will be very high. Why it is, I'll tell you. The tendency will be very high if you have a standardized process. All of you, do you have a do you always have a standardized process? Yes or no?
Yes, sir. Yes,
Your
sir.
process is standardized. Your process is monitored. Your process is controlled. If these things happen, your data should follow bell curve. If data doesn't follow bell curve, there are few possibilities. Either the data collected is very less, or otherwise the procedure is not followed. The procedure is not followed. Though the process is standardized, it is not followed. So that's why the process standardization and respecting the SOPs are very, very important. And so that we will be able to understand the real nature of the process. If people don't respect the given procedure and do it as per their way, then the behavior of the process cannot be understood properly. Okay, so those are the times your bell curve will get disturbed in its shape. If the bell curve shape is getting disturbed, the bell curve is called yes, the distribution is called skewed distribution. The distribution is called skewed distribution. Otherwise, it will be normal distribution. Why the skewed distribution comes? The standardization is not respected. Yes or no?
Yes.
So all of you are supposed to join the session by 7 p.m., isn't it?
Yes.
Okay, but many people joined late. So what happened? Those who joined very late, they are called outliers. They are called outliers. If there are outliers, what will happen if the outliers are more? If the outliers are more and all of them on one side, then the mean of your process will get shifted. Correct? If there are too many points on the right side, then what will happen? The mean will be pulled towards that side. Yes or no?
Yes.
If the mean is pulled towards right side, then what will happen? The tail on the right side will become longer, and your distribution is now called skewed distribution, called right skewed distribution or positively skewed distribution. So skewness, your bell curve will experience skewness simply because there are outliers, and which means your process has undergone a shift. So your process undergoing a shift, is it good or bad? Tell me.
Not good, sir.
Not good.
Not really good.
Not good. Bad.
So we need to check whether our process is experiencing any shift or not. If my process experiences shift, then I will immediately stop my process, investigate what is exactly going wrong. I will try to figure out the root cause, and then I will take the appropriate action and ensure the outliers are removed. My mean is again pulled to the targeted location. This is what you will be doing while driving a car also, isn't it? Let's say your car, on its own, it is shifting towards right. Will you just keep quiet? You know what will happen, no? If your car is shifting towards right, yes or no? You will definitely either stop or slow down the car and put all efforts to ensure your car, comes to your control, isn't it? So that this is what we are also doing with the CP/CPK study. CP will tell you whether your car is smaller than the bridge or bigger than the bridge. Or in other words, CP will tell you whether your process has a tendency to overconsume the tolerance or not. If your process consumes tolerance excessively, that is more than what has been, provided by the customer, then those times CP will go below 1. Are you getting my point? Any month, if you spend, if you spend your monthly expenditure more than the earned money, you are going to be in trouble in that month. That is what the CP will be indicating. So CP less than 1 means your process is bigger than bridge. And your process is always expressed by Six Sigma. What is Six Sigma? The spread of the process. Spread of the process is more than USL minus LSL.
Sir, this can be given industrial example. Actually, so car is given example. It is purely understand. That same be given through that industrial example.
Okay.
Example will we can understand better.
Uh,
We can
No, no,
compare
no.
and
You
understand
first
better.
understand the simple example, and then we will take your example also.
Yeah, yeah.
Which type of industry you work?
SCM, sir, supply chain management.
Okay. So can you tell me one continuous metric that you deal?
Like receiving stocks from suppliers, actually.
So receiving stock from supplier, how do you measure? Do you measure lead
So
time?
yeah, lead time as well against PO whether we are getting it or not. So example, we are ordering so it's around 1,000 units for any kind of shirts or any kind of material that will be matched with physical material.
See, you
So
map your arrived, see, you mapped your arrived quantity with the ordered quantity, right?
yes.
I have clearly told you, if you are working with the numbers, you cannot do the CPCPK study there. If you are
Numbers only,
working with
sir.
the numbers in the sense counted number, you do not have a unit, no.
No,
1,000
no.
numbers arrived. 1,000 numbers is 1,000, but
Thou-
you
yes,
have to
yes.
measure
1,000
in
numbers.
kilograms, you have to measure in millimeter, you have to measure in degree Celsius. Some way unit of measurement is required. If you are talking in terms of lead time, then some days, some hours. In those cases, CPCPK study is applicable.
Yeah,
All of
lead
you.
time applicable, which means we are taking a shipment from Mumbai to Chennai
So,
around 4 to 5 days. So they are delivering us actually within
so
7 days
my
means.
suggestion is, wait.
Uh,
My suggestion to you is first listen to me and first try to understand the concept and try to understand the prerequisites. Very important. Just
okay.
because you studied something, you don't try to use it, everywhere. It will not work. Even
Okay.
after you study the CPCPK, you become an expert in, CPCPK analysis. First, ensure, study the situation, whether CPCPK study can be meaningful to assess the capability in a particular situation. There are many other tools, similar tools, first pass quality, isn't it? First time quality, first pass quality, first time right, and defect rate, PPM, DPMO. There are many things available to measure the baseline. But I started by saying that CPCPK study is required only if the output is measured in the form of a measurable characteristics. Okay. So understand the concept and then, you can replace, you can bring anything, lead time, you can bring surface finish, you can bring hardness, you can bring, what you call any metric, any measurable metric, fat content or melt flow index, whatever it is, or boiler
Oh,
efficiency. For all those things, we can check the CPCPA. So
See,
don't
our
worry,
okay, sir.
you will be, yeah, you will be able to apply.
Because don't have that manufacturing industry that experience, so that it is applicable for STEM sector.
I know that. I
That's
know
what
that.
uh,
I know that. That's why I'm talking, like a bridge and a car.
yes.
sir, ours
Right?
is
Okay, understood.
actually
You can
uh,
relate. You
ours
can
is
relate.
like a ours is like a noodle industry, noodle manufacturing industry.
Or
Now,
noodles manufacturing. Noodle
yeah, noodles
manufacturing is also manufacturing only.
manufacturing, but measuring continuous data, we are measuring like a frying temperature in the line.
Very good. You apply CPCPK there.
Yeah, in that we have a limit actually, lower and upper.
All right. Just wait for a few minutes, then you will be able to apply. All of you can apply to your domain. All right. So there is LSL, there is USL, and there is target. Now you are familiar with all these things. Target, USL, and there is LSL. All right. And now there is a process. And in the process, there is a spread. The spread is Six Sigma. And here the tolerance is defined like this, USL minus LSL. Now we just have to take a ratio. We just have to take a ratio. You know what is the ratio? USL minus LSL divided by 6 sigma. And this is known as CP. Now, please tell me if the process spread is smaller than the tolerance given by the customer, automatically your CP will be more than 1, yes or no?
Yes.
If the
Yes.
denominator is bigger than, if the denominator is smaller than the numerator, your CP will be more than 1. So what is not preferred here is the denominator should not be bigger than the numerator. So what is denominator? The spread of the process. The spread of the process, if it is smaller, the process is considered to be consistent. Yes or no? The process
Yes.
is considered to be very consistent. And but if the denominator is, let us say, the wider, then the process is highly inconsistent. That means more variation. That means more variation. So with the help of CP, you can easily understand whether your process is potentially capable or not. And if CP is okay, okay means more than one. But there is a guideline, AAG guideline, and that says CP should be more than 1.67 for all critical characteristics. Suppose if the requirement is, the area where you apply CP/CPK is, it's a less critical area or a non-critical area. Even CP of more than 1.33 is enough. So you can take a call whether the characteristics is very critical and it is specified by the customer, then go for 1.67. But if it is if it is purely internal and not so critical and failure is not going to be very dangerous, in such a case, you can go for a CP of 1.33. Is that clear, all of you? And now this is the logic behind CP. And please understand, in order to calculate the CP, you only need USL, LSL, and what you need? Sigma. Okay. And how to calculate the sigma? Can you tell me what is the sigma actually? The sigma is
Standard
Deviation.
deviation.
process standard deviation. Sigma is process standard deviation. And please note, when we say this sigma, you have to use a specific formula here. What is this formula? R bar by D2. When you want to calculate this sigma, the formula you must use is R bar divided by D2. And I bring additional terminology here. The sigma is actually sigma within. Sigma is actually what? Sigma within. I will tell you the meaning of within. I'll tell you the meaning of within. Sigma within. And the formula should be R bar by D2. Just remember this. I'll tell you what is R bar here, what is D2 here, and everything. Okay. So when I say CP, the formula is USL minus LSL. Hereafter, I will write like this. It's not just sigma, it is sigma within. It is not just sigma, it is sigma within. So it's a type of standard deviation. You have to calculate the standard deviation in a particular way, and that way is also indicated here. What is that? R bar divided by D2. Now, one more condition when you want to do a CP/CPK study. The first condition I told you is data type must be continuous. Another condition is data must be collected in subgroups. What does it mean? Data must be collected in subgroup. What is a subgroup? A group of samples collected simultaneously is known as a subgroup. Do you all understand what is a subgroup? When you go for data collection, when you go for sample collection, you are expected to collect samples in group, minimum 2, maximum 25. Every time when you take a sample, you are expected to take either 2 samples simultaneously, or 3 or 4 or 5, or up to what? 25. And then the subgroups must be selected in appropriate time interval. Are you with me? Which is called, sampling frequency, which is called sampling frequency. Let's say a quality engineer, he is collecting samples 5 at a time. He is collecting samples 5 at a time, and every 2 hours once he collects 5 samples. Now tell me, what is the sampling frequency?
2 hours.
2 hours once. And what is the
Yeah.
subgroup size?
5.
5. Very good. And in 10 hours, he will have 10 subgroups in his hand. In 10 hour time, 2 hour one means 5 subgroups. 5 times you would have taken a sample. Are you with me, all of you?
Yes.
5 times he has taken a group of 5 samples. And now with this information, you should be calculating sigma within, which is nothing but R bar by D2. I'll just tell you, what is R bar? Average of the ranges. R bar, what is R bar? Average of the ranges. One quick method is, straight away you can look at R control chart. All of you, do you know R control chart? There is a control chart called R chart, isn't it?
Yes.
In the R control chart, there is a center line. That center line is nothing but R bar. That center line is nothing but R bar. You can pick up the R
Average.
bar from there.
Okay.
All right. Another thing is subgroup number 1,
On average
subgroup
will
number 2, subgroup number 3, subgroup number 4, subgroup number 5. In subgroup number 1, how many samples you have? 5 samples.
come. 5 samples.
Can you find out the maximum out of the 5?
Yes.
You can also find out the minimum out of the 5.
Yes.
The difference between the maximum and minimum is nothing but R1. Am I right? And similarly for subgroup number 2, it is R2. Please, all of you, don't worry about the calculations.
Okay.
Finally, you should know what you need to do. Collect the data and feed it either in Minitab, or you can have an internal template. Just put it. All these same formulas will work, and then result will come, right? So it's as
Yes.
simple as collecting the data in a correct manner, feeding it, getting the result, and take decisions. But just for knowledge purpose only, I'm explaining everything. So subgroup 3 will give you R3, subgroup 4 will give you R4, subgroup 5 will give you R5. Now with R1, R2, R3, R4, R5, please tell me, will you be able to calculate R bar?
Yes, sir. We'll take
What is
the
R
average
bar?
of all the
That's all very simple. R1 plus R2 plus R3 plus R4 plus R5 divided by 5.
divided by 5. Yes.
Now this R bar value must be divided by a constant known as control chart constant D2. And this is, this is a control chart constant. And see here, I will straight away, I'll show you.
D2 also.
Control chart constant D2 value, very simple. For different values of n, you see here, it is coming. This is correct only. And see here, for value of for a subgroup size of 5, D2 value is how much?
2.36.
2.326. Or you can also go to any standard book, and that book will certainly have what? The control chart constant in the annexure. Or we can also pick up a table here. You see here, anything we can take. This one will take. Yeah. So we'll open this. Now you tell me. For subgroup size, n equal to 5. N equal to 5. Where is D2? Oh, D2 is in the end. Can you tell me how much is the D2 value?
2.36.
That's all. You know R bar, you know D2. Please apply that. Your sigma is calculated. Sorry, your what do you call? Your sigma within is calculated. Now, the calculated value you must apply in CP formula. You must apply in CP formula. Because what is CP formula?
USL minus LSL divided by 6 sigma.
Now for normal professionals, it is 6 sigma. But for the green belts here, black belts here, it is 6 times sigma within. What is that?
Times
6 times
sigma.
sigma within.
6 times
Sigma within.
sigma within. Standard
Mhm.
deviation, there are different types of standard deviation available. Keep it in mind. One by one, you must understand. Now, sigma within means within standard deviation. Sigma within represents variation within a subgroup. What is the significance of sigma within? If you are the plant head, if you are the plant head, if sigma within value is shown to you, what do you understand? Take the same scenario. 2 hours once, your quality
Collect the
engineer
sample.
is taking a sample of 5 and he calculates sigma within, right? And then, he is showing you because sigma within is calculated out of range only, isn't it? So he calculates range and plots the range, in a R chart. If you see a point, falling, completely outside the limits in a range chart, will you not be worried about the outlier?
Yes.
What does it mean? If the range falls outside the limit, what does it mean?
It's
The
6
two,
sigma.
the production you produced in that 2 hours is under risk. Yes or no?
Yes, sir.
Yes.
What are the units needs to be 100% inspected now? The parts produced during the 2 hours only, isn't it?
Yes.
You need to check the parts produced within that 2 hours. The range is helping you to understand the variation within that 2 hours. That is why I want you to call that standard deviation as within standard deviation. Do you understand, all of you?
Yes.
Yes, sir.
So within standard deviation, if it is controlled, you can understand, the 2 hours went on in a consistent manner. If within standard deviation is out of control, the maintaining consistency within the 2 hours itself is a problem. Say, for example, this session is going to be for 1.5 hours. All of you, please tell me, will you be able to concentrate fully? Is it possible for you to stay concentrate, stay attentive throughout the 90 minutes? Is it possible or not?
No.
Not possible.
Not possible, right? Definitely. It is, if it is possible, your within variation is under control. If it is possible, your within variation is under control, isn't it?
Yes, sir.
So this is the significance of within variation. Sigma equal to R bar divided by T2. Okay. But this alone is not enough. I already told you this alone is not enough. You need to have a car smaller than the bridge. At the same time, you should also be driving the car in a proper manner. If you want to drive the car proper manner means in through the center of the bridge. So how do we understand whether we are driving properly or not? So for that, see here, there is subgroup number 1, there is subgroup number 2, there is subgroup number 3, there is subgroup number 4, and there is subgroup number 5. And here is your R1, R2,
What
R3, R4, R5. Now I want you to find out X1 bar. What is X1 bar?
X1 bar
The
is R1
average
average.
first subgroup. And this is average of the second subgroup. This is average of the third subgroup. This is average of the fourth subgroup. Average of the fifth subgroup. If all these averages are close to each other, you are driving more or less straight. Yes or no? If your averages are far away from each one, then you are driving like this. This is not good actually.
Not improper. It's
So
improper.
you should not only monitor the R value, you should also monitor the X
Average.
bar. That's why we always have an X bar R chart. Do you remember, all of you?
Yes.
We
Sir,
always
I'm
use a chart.
confusing in R and X. Earliest you said ki R is a average of a matlab, reading, and now you're saying X is a average of readings.
Wait. R is range. What is R bar?
Average.
Average of
Range.
range.
Average of the ranges, right?
Range.
Okay.
R refers to range. Now, but X bar, see X bar refers to sample
Subgroups.
average
Subgroups
or
average.
subgroup average.
Yes.
There are 5 averages, isn't it? X1 bar, X2 bar, whatever is the number of subgroup, you will have so many averages. And now you can take average of all the averages. That will be grand average.
That is
This,
R bar.
okay, we'll go with some data. See, you have to very carefully listen to my explanation. Then only you will be, able to travel with me. If you check with me, just intermittently, then it will be difficult for you. Sometimes, explaining the concept in a detailed way will be, will become, difficult to understand. But if you follow, then you will have a good command over the subject. All right. So no issues. Now, what is the software I opened right now?
Minitab.
This is a Minitab software, right? Minitab. Okay. So let me also pick up the data. So in that, let us go to diameter. So wherever you have continuous data, then the study is feasible. And see here, I have picked up a sheet named coating thickness. It's a manufacturing scenario. A coating process is happening and the coating thickness required is 50 microns. Coating thickness required is 50 micron. And customer has given a tolerance plus or minus 3 microns, right? And now the company is monitoring the process. Let's say every 1 hour they are changing the roll because the raw material comes in the form of a roll. So every 1 hour they change the roll, and for every roll they are selecting 3 samples. What is the subgroup size here?
3.
Subgroup size is 3. And continuously, you see, the process is going on, monitoring is going on. 7th roll, 8th roll, 9th roll, almost 25 rolls finished. You see, now there are 25 subgroups of data you have. What do you have? 25 subgroups of data you have. So I just paste this here. See here. Oh, sorry. Control is here. I should paste here. And this is thickness. And this is roll number. This is roll number. Okay. So now what I need to do is, first of all, I need to check whether the process is stable or not. What should I do? I need to check whether the process is stable or not. See, all of you, if you want to perform a capability study, you have to first check whether the process is stable or not. How do I check whether my process is stable or not?
Average of a subgroup, like average of a one subgroup, average of a two subgroup.
No, it's a simple logic, right? So let me type something here, right? And a process needs to be stable for studying its capability. Okay. A process needs to be stable. And how do I know whether my process is stable or not? The process is stable or not is nothing but we are checking whether it is free from outlier or not. Are you getting it?
Okay.
What is an outlier?
50.3.
The extreme cases, the values which are far away from the center are known as outliers. In control chart, points found outside the control limits are considered as outliers. Are you with me, all of you?
Yes.
So first, before studying the capability, you must study the stability. And now what should I do? I should visualize the data in a control chart. Are you with me, all of you?
Yes.
And which control chart I should use? Which control chart? I should use a control chart for variables. Am I right? I should use a control chart specifically meant for variable. There are 3 charts available. Can you tell me all of them? First one,
Yes.
X bar R chart. Second one, X bar S chart. And third one, IMR chart. Okay. There are 3 charts meant for no variable data or continuous data. And now this depends on subgroup size. Now X bar R chart can be used when the subgroup size is less than or equal to 8. Then when can I use X bar S chart? When the subgroup size is more than 8. When can I use IMR chart? When the subgroup size is just 1. That means individual data. Are you with me, all of you? Come on, please confirm. Are you following me?
Yes,
Yes,
sir.
yes, yes.
So now
Yes, sir. Yes, sir.
which control chart is more appropriate for the given situation?
X bar R chart.
Very good. Let us plot an X bar R chart. First, let us ensure our process is stable. Then only we should proceed with capability study. Okay. So go to stat, go to control chart, go to variable chart for subgroup. Then you have X bar R chart. And look at the description. Can one of you read out the description little louder?
Monitor the mean
Monitor the mean and
and the variation range of your process when you have continuous data in subgroups. Works best with subgroups size of 8 or less.
We are in the exact situation. So use the X bar R chart. Now this window will come. Which is L. So all observations are in one column. Yes, I have it in column number 5. So I choose this option, click my cursor here. Now I have to choose C5 thickness. Select. Subgroup size. Now I have to tell the subgroup size. You know what is my subgroup size?
3.
3.
3.
I can type 3 or I can input column number 6 for that matter. Now X bar or option. What is out of control for you? I will go to the test. Any point found outside the control limit is an outlier for me. Look here. A point more than k times standard deviation and the k is equal to 3. That means what? A point 3 standard deviation away from the center is the definition for outlier. Yes or no?
Yes, sir.
Do you
Yes.
understand, all of you? The first thing you should know about an outlier is in control chart, the definition of outlier is a point seen outside the control limit is an outlier. Do you understand, all of you?
Yes.
Yes, sir.
Right? The first definition of outlier is point found outside the control limit. So I am giving that. I'm saying okay. Now you please look at your control chart. Now, all of you, please look at the control chart and tell me whether your process is stable or not.
No, not stable.
Not
So,
stable.
what should you be doing in this situation now?
We have to
What should you be doing now?
standardize.
Shall I proceed and calculate the CPCPK, or should I, immediately,
Stop the
Stop the
X4
start
under.
my
process. No,
process?
no, no.
So, in this situation, all of you please note, in this situation, proceeding further and calculating the CPCPK can be misleading also. How many of you agree with me?
Yes.
Yes, yes.
Since there are so many outliers seen, now it can be misleading. You can calculate if needed, your boss is asking, your company is asking, but you tell them there is a lot of uncertainty involved right now. What is that uncertainty? So many outliers. What should you do? You should put efforts to eliminate the outliers first. Are you getting it? You should put efforts to eliminate the outliers. For each and every outlier, you try to find out the root cause. First, check whether it's a kind of a random mistake or it's a recurring mistake. If it is a recurring mistake, an action is required. Right? If it's a recurring mistake, an action is required. Find out the root cause, take the correct action, then the outlier will not reoccur. There is an assurance that the occurrence of an outlier is eliminated. Yes or no? This document you must maintain. For each of the outlier, you maintain an action taken report. If no action is required, you have to mention why no action is required. Do you understand?
Yes.
Right now, let's say in the training, suddenly you slept. It's a situation of outlier, yes or no?
Yes, sir.
Yes.
And now you need to ask yourself, is it what is the root cause of it? Is it a random or regular? You always sleep in all classes or rarely only you sleep? It's a random, right? It's a random. So if it is random, okay, you allow the process to continue with some kind of warning and other things. You can allow the process to continue. But if it is recurring every time, then some investigation is required. If you have some sessions, take enough rest earlier, isn't it? Some arrangement is needed. And then make sure you are available dedicatedly for the session. If all these things are there, then with peace of mind, yes, definitely you will be able to concentrate. So you are actually fixing the root cause. This kind of action is required. Once such actions are taken, record is maintained, you can eliminate all the red color points. You now have a fresh set of data. Do you understand what I'm telling?
Yes.
In your control chart, those red color points, outliers, they can be removed. After the red color points, outliers are removed. Now, if you proceed and calculate CP/CPK, it will not be misleading. It will be very realistic CP/CPK. How many of you agree with me?
Yes.
All right. So let us proceed now, because we now have data and we have seen our control chart with so many red color points, but still I would like to show you how to do the capability analysis in Minitab. So go to stat, go to quality tools, go to capability analysis, then go to normal. Clear? Stat, quality tools, capability analysis, normal. Determine how well your process output meet the customer requirement when your data are reasonably normal. Click. Now single column. Where is that column? Thickness C5. Click select. Subgroup size as usual, again 3. Lower spec and upper spec. Customer wanted a thickness of 50 microns plus or minus 3 microns. Now tell me what is the lower spec? 47 microns. Upper spec 53 microns. If you give this much data and you give OK, and Minitab will do the max for you. Now all that you need is, can you read this, one of you, what is written here? Potential
Within capability.
within. That's why I brought the word within. Now you are familiar with within. Within means R bar by D2. That R bar by D2 gives you within standard deviation. You see here, how much it is within standard deviation?
0.40.
0.40608. And this 0.40608 formula is R bar by D2. Now CP is 2.46. Are you happy? You are very happy.
Yes.
You are very,
Very
very happy because the industry requirement is 1.67 only. But your process is performing in a superficial manner.
Yeah.
Yes or no?
CPK also more, sir.
Yeah, CPK also super, 2.37. This is because your customer has given a very liberal tolerance.
Yes. And process
Customer
is
has
not
given very
standardized.
liberal tolerance. Your pass mark is just reduced to 20 marks only.
Yeah, this is the 33 marks out of 100.
Yeah, just 33. 33 is the pass mark. Very easy to score situation. That is why, in spite of the instability, your process still remains what? Capable. That's a good sign. But it doesn't mean you can completely ignore the situation. Yes or no? 2
Yes.
points. See, your pass mark is 33 only, but you scored 90 plus. But still, it is a good idea to check where and all you went wrong, isn't it? Questions where you slipped. Same manner, there are certain situations, where you are out of control. So what can we do? 1 minute. We have
One
to go
question
to
here.
1 minute. 1 minute. Go
Hello.
to the graph. Yes, sir. Please.
One question here, sir.
Yeah,
The
please.
process capability report, it is coming out from with the help of Minitab only, right, sir?
Mm-mm-mm.
So manually, any numerical or anything for method to calculate any example, manual is not possible.
We cannot say it is not possible. The same problem can be done manually also, right? But then it will take time. That is why even the CPK concept I did not explain. I only explained all of you CP, isn't it? Right? So don't worry. You will understand. You will understand the Excel sheet. The manual calculation is available. You can even just understand like R1, R2, R3, R4,
Yes,
R5.
yes,
Everything is
yes, yes,
calculated manually. You
yes,
can
yes.
understand. Yeah. All right. So first let us understand, the output. This because this is much easier. Everybody wants the shorter routes nowadays, but definitely deep learning is also required. So CP is 2.46, extremely good. CPK is 2.37, extremely good, but still maybe as a quality head or plant head or whatever position I am worried about the control chart. Is my worry correct concern or I am unnecessarily over projecting it? Tell me all of you.
Correct concern, sir.
Um, my concern is correct, right? So I must necessarily ask my team the reason for all these outliers. I must necessarily ask my team the reason for each of the outlier. Do you think they will be able to give me the correct root cause if they've already wasted 2 weeks' time?
No, no, no.
No. Then I should have raised the question, then and there. Immediately, whenever a point falls outside the control limit, immediately question must be asked, and the situation of instability must be studied and must be corrected and must be documented. When you are going to an external place for auditing, you must check all these things. Are you getting it? If you are an auditor, you must necessarily ask why actions are not taken. So many signals have come from the control chart. All of them were ignored simply by saying that CPK is 2.46, 2.37. Will you ask such question, all of you?
Yes. Yes,
You
yes, we
must
can ask.
ask. Then only you are doing your job. Otherwise, you are simply believing everything is true, and everything cannot be correct. So CPCPK is valid only if control chart shows stability. When CPCPK is valid, when control chart shows stability. If stability itself is a question mark and CPCPK can be misleading, but however, in this situation, still, the CPCPK is healthier, acceptable. There are no rejections. You can see. There are no rejections. You see here. Look at this is called within capability. And see, come to the within side. You see here within side. What is the PPM? Parts per million rejection.
Zero.
Zero.
Everything is zero. It's a zero PPM scenario, but still you have an opportunity to improve.
Sir, if there is this variation is tolerated, then in future it will lead to more variation and finally error will come.
Very good. If you tolerate the variation right now, not you can tolerate variation. There are two types of variation. One is common cause variation. Another one is special cause variation. You can tolerate common cause variation, but not
Special
special
cause.
cost variation. So special cost variation, if you tolerate, and that will definitely lead to many problems in the future. And see here, a warning has already come to you. You see, in the future, your ppm can increase to 394. But when is that feature? When is that future? Is it going to be tomorrow or next week or next month? It depends on the situation. But statistics is telling you your ppm can increase from 0 to 394. If each part is going to be cost you, 10,000 rupees, then 394 ppm can lead to a big money. Are you with me, all of you? Now here we need to understand one important thing, CPK, isn't it? Because I have not explained you the formulas of CPK. We literally we jumped to an example. So now I will write what is CPK. So CPK, the formula is minimum of CP upper, comma, CP lower. Sir, what is this CP upper and CP lower? Please tell me, if a process shift to the right side, the process is shifting to the right side. You are driving a car over the bridge and your car is dragging towards the right side. Now, which side you are expected to fall down? Which side the risk is increasing? Right side, isn't it? If your car is shifting to the right side, then CP upper will become the CPK value. If your car is shifting to the left side, then CP lower will become the CPK value. As the risk increases, the CP upper and CP lower value will decrease. Whichever decreases, that will be assumed as CPK. Now let us understand what is CP upper formula and what is CP lower formula, and I will just write it for you. The CP upper is nothing but the distance between your cell and the process center. Wherever is your process center and the nearest spec, the right side is upper spec, divided by, since we are now focused on only one side, total spread of the process is how much? 6 sigma. Now it is only one side, so it is 3 sigma. Do you understand, all of you? USL, the distance between USL and X bar. And the same time, let us calculate CP lower also. CP lower means X bar minus LSL by 3 sigma. If you are driving the car in a very sensible manner, exactly through the center, there is no shift at all. Right side also no shift, left side also no shift. In such a situation, I am telling you, CP upper will be equal to CP lower. Do you agree, all of you?
Yes.
Yes,
If
sir.
my
Mid
car is
position.
exactly going through the center, there is no shift to the right side, no shift to the left side. In
It will
such
be
a
equal to
situation,
mean. It will be equal to average mean.
very good. CP upper will be equal to CP lower. But if you do not drive properly, if you shift your car to the left side or if you shift your car to the right side, that situation, please understand, CP upper will not be equal to CP lower. Correct? So in this situation, you must take the minimum of the two. Why minimum? If CP upper goes down, you can understand your process shifted to the right side. Am I right? If CP lower goes down, your process shifted to the left side. And the formula for CPK is very simple. CPK is equal to minimum of CP upper, comma CP lower, isn't it? Now the formulas are revealed to you, all of you. Now tell me, what is the formula for CP upper? What is the formula for CP upper?
USL minus X bar
USL
divided by
minus
3
X bar
sigma.
by 3 sigma.
Very good, beautiful. So
Sir, I have a
I'll just,
question.
yeah, please.
Yes. Sir, when we calculate the upper sigma, X bar, the formula is USL minus X bar oblique 3 sigma.
Correct.
But in case of CP lower, why we put LSL later than X bar.
We put X bar minus LSL by 3 sigma. This is the formula. I will also visually show it. Once I visually show it, then you will be able to relate very much. So the formulas are now known to you.
Yes, sir.
And Minitab is also, available with you. Minitab is going to do everything, just with a matter of clicks. And since you wanted to also know the things manually want to do, let me also present, the slides. And there are some examples available, and you can relate it very easily. Okay. So I'm just sharing. Please note, in any case, when you do the CP/CPK study, whatever I have told you, keep it in mind. Process must be stable. First point. And another thing is, first of all, data type must be
Continuous.
continuous. Process must be stable.
Stable.
And the sample must be collected in subgroup.
Groups.
And for first subgroup and second subgroup, there must be a time interval. If you do not maintain any of these conditions, you are actually not calculating CP/CPK. You are calculating something else. Do you understand, all of you? Please do not violate any of these things. But if violation happens, at least you should know what is happening. Say, for example, control chart is unstable. You must know your CP/CPK can be misleading. Right? Okay. So now let's look at the slide. And now we can take any example that you want to discuss, right? Because everything is now understood. And now, okay. Yeah, see here, process capability indices, CP and CPK. CP is potential process capability ratio. CPK is process capability index. And formula is USL minus LSL divided by 6.
Sigma.
Yes.
Within.
See, sigma means standard deviation of population. S means standard deviation of sample. Are you aware of it, all of you? So it is more appropriate to use S only, because we are working with sample data, right? 1 point. And now this standard deviation here is nothing but an estimated standard deviation. The formula for the S is, what is the formula for the standard deviation? I told you. What is the formula for the standard deviation? Very
R bar
good.
by
R bar by D2. Remember this. And now the S is available. USL is known. LSL is known. And X bar. What is X bar? The
Average.
process average. Process average, right? So
Average of subgroup 1.
very good. Average of subgroup 1. And now there is CP upper, there is CP lower, and we calculate we find out the minimum of it, and that will become what? Your CPK. Very simple. Correct. So the formula is again, understood. So we now proceed. And see here, look at my process, look at the specification, and tell me whether this process is capable or not. Is this process capable?
Yes, capable,
Yes,
sir. Capable.
Definitely capable.
within the
Visually, you
lower
can
and upper
confirm.
specification limit.
I'll tell you, visually, control limits are seen inside the specification, isn't it?
Yeah, yeah, yeah.
And
That is
another
why.
thing is CP equal to 1.67. And one more thing is process is not shifted to the right, not shifted to the left. It is placed centrally. Can you
Centered.
see?
Yes.
Yes.
Yeah, yeah.
Whenever process doesn't experience shift, CP will be equal to CPK. You don't have to calculate CPK. Even if you calculate, it will be same. When CP is okay, your process is consistent. When CP is okay, your process is consistent.
Consistent.
When CPK is okay, your process is capable. If both are okay, your process is consistent and capable. Do you understand, all of you? process is consistent if CP is okay. Your process is capable if CPK is okay. If both are okay, your process is consistent and capable. What we want is, we want a capable and consistently capable process, which means we want our CPK to be equal to CP. Do you understand, all of you?
Yes.
We want our CPK to be equal to CP. That means you have reached your ultimate. What is possible you achieved. What is possible? The maximum good thing that can happen is CPK equal to CP. And your CPK should be whatever is the condition, 1.67 or even more you can achieve, more you can try. And CPK, when you make it 2, the process capability becomes 6 sigma capability. If CPK is 2, what is your process capability? 6 sigma capability. It is CPK, when multiplied by 3, you get the sigma level. CPK 2 means sigma level will be 6. Okay, so visually you have seen. Now now look at this process. Now what happened to this process? Tell me, all of you. What's wrong here?
Average is shifted towards upper side.
Process is shifted to the right side. As a result, can you see the curve going beyond specification? So this area is a rejection, yes or no?
Yes.
Yeah.
In this situation, saying that my process is capable is an useless finding. Your process is just consistent. That's all. It has the consistency, stability is there, but capability is not there. Already rejections are happening. Only CP is okay, acceptable. CPK is unacceptable. If you calculate CPK in this situation, you come to know your CPK is going downwards. Now see here, in order to help all of you understand the concept of CPK, I have divided the customer tolerance into 2 parts. Can you see? Blue color tolerance and green color tolerance.
Yes.
Yes, sir.
They are equal. Similarly, process spread also I divided into 2 parts. 6 sigma becomes 3 sigma and 3 sigma. Why am I doing this? Just checking whether my process is shifted or not. If my process hasn't shifted, look here. The right side ratio, blue bar by 3 sigma, will be equal to left side ratio, green bar by 3 sigma. When it is true, if there is no shift. If my process is shifted, the ratio will become unequal. Yes or no? Unequal means one side the value will go down. If the right side value goes down, then CP upper will be assigned to CPK. If left side value goes down, then CP lower will be assigned to CPK. All of you, do you understand the logic, concept?
Yes.
Come on, do you understand or not?
Yes, sir. Understand.
Okay.
Yes, sir.
Yeah. So you have to listen very carefully every single minute, then you will certainly understand. And now see here, a process got
Sir, in that
shifted.
case, CP is equal to CPK. No?
Yes, in this case, here it is CP equal to CPK. Very good. Look here, CPK is 1.67. You no need to calculate CP. CP will also be 1.67. You calculate any one, automatically the other one can also be given the same value. And now here it's a situation of shift. So CP and CPK will be different. Look here, CPK has become 0.83 and CP can be much higher even in this situation.
Yeah, CPK
So,
is the issue.
CPK. Come on, tell me. CPK?
Yeah, CPK is the move. Move the right side.
CPK will check whether your process is shifted or not. But
Yeah.
CP do not check. It will only compare the spread with the tolerance. But CPK will compare the spread with the tolerance as well as check whether any shift has happened. So if shift happened, then that also will be captured. So ultimately, what we want is, we want CPK to be equal to CP. Whenever you see CPK equal to CP, please understand your process hasn't shifted. The process mean is on the target. There is no shift. But the moment you understand CP, CPK are different, you need to understand your process has shifted either to the right side or to the left side. Do you understand? And moreover,
Understand.
we want the CPK to be more than 1.66 or 1.67. And of course, whatever applicable to CPK, they are applicable to CP also. And now let's take one example. First example, let us take this. Can one of you read out this situation? We will discuss.
For an electronic manufacturing process, the specification for current flow is 100 plus or minus 10 milliampere. The process mean and estimated standard deviation are 107 and 1.5 respectively. Compute CP, CPK.
Okay, thank you, Mohammed. So Mohammed has told the specification is 100 plus or minus 10, which means USL is 110 milliampere, LSL is 90 milliampere. You see here, USL is 110, LSL is 90. And Mohammed also said the data is collected and process average is 1.107. Estimated standard deviation is 1.5. Please note, straight away one of the standard deviation is given to you. What is the standard deviation? Within standard deviation. What is the standard deviation? Within standard deviation. What is the formula to calculate this 1.5? R bar by D2. Without a control chart, you can't calculate R bar by D2. Always capability study requires a control chart. Okay. So now here, no, the situation is simplified for you to know better understand. So R bar by D2 is applied, 1.5 is directly given to you. Now you have to calculate CP. CP is specification width divided by process width. Specification width is USL minus LSL. Process width is 6 sigma. And this sigma is 1.5. This USL is 110. LSL is 90. If you substitute all these things, your CP equal to 2.22. Now, please tell me what is the inference? If you read CP equal to 2.22, what does it mean? Now, can you say your process is capable or can you say your process is consistent?
Consistent.
Process is consistent.
Consistent. Consistency is otherwise called potentially capable because consistency is the key to everything. So consistency means potentially capable. So now we move on to CPK. Formula is minimum of CP upper, CP lower. What is CP upper? Minimum of USL minus X bar by 3 sigma. And CP lower is X bar minus LSL by 3 sigma. We substitute all these values. CP upper is found to be 0.66. CP lower is found to be 3.77. When you have two different value, which value we should assign to CPK? Minimum or the maximum?
Minimum.
Minimum.
Which is 0.66 in this case. So CPK equal to 0.66 confirms our process has lost the capability. Our process has started producing rejections. Isn't it? Our process is not capable but consistent, which means there is no problem with the variation. The problem is with the center. See here, the inference is move the process mean closer to the target. So what to do to pull back the mean towards the target? You have to brainstorm and you have to take some suitable action. All of you, have you understood this problem?
Yes.
Yes.
Please
Yes, sir.
confirm.
Yes, sir.
Yes, sir.
Yes.
Yes, sir.
Very good, very good. So now another example. Now hereafter, now the situation, any situation we can handle. Any situation, even your supply chain situation or any situation. But you have to speak in a crystal clear manner. You have to tell what is the metric which is important to you. What is the target value for the metric? What is the upper tolerable limit? What is the lower tolerable limit? And have you studied the process? Have you collected the data? And how did you collect the data? Have you collected the data in subgroup? And and have you maintained some time interval between the subgroup? All these things, ensure. And then X bar value and what you call sigma within value are required. And now there is another problem. It's an extrusion die used to produce aluminum rod. The diameter of the rods is a critical quality characteristic, CTQ. The specification of the rods are 0.5035 plus or minus 0.0010. The process average is 0.5031 and the estimated standard deviation is 0.0003. Right? And I already explained the formula and everything, but the problem, doesn't really complicating you. but the complications are already solved in the background, R bar by D2. Now compute CP/CPK. USL is available, LSL is available, X bar is available, sigma is available. All that you need to do is substitute and get the value. Now please tell me, CP is calculated to be 1.11. Are you happy with the CP now?
No, sir.
No.
No. Though it is more than 1, which seems to be generally okay, but according to AAG guideline, if directly or indirectly you are related to automotive application, AAG guideline, minimum of 1.33 is required, and that too, if it is a critical characteristics, 1.67 is required, and that's not happening. So CP is unacceptable. Now CPK. And please note, if CP is 1.11, CPK cannot be more than CP. CPK cannot be more than CP. So we apply the formula for CPK, and CPK is found to be 0.66. CP is also under trouble.
Yes.
CPK is also under trouble. Now the worst thing that can happen, right? So your mean is also not at the targeted location. The spread of the process is also very high, which means your car is also wider and your driver is also a problematic fellow. Now you have to cross the river. Very dangerous situation you are in. Yes or no?
Not possible.
Not possible. And this is so you need to change the situation. How will you change the situation? You need to stop the process first. Investigate,
पेट्रोल डलवा
correct,
दिए उसको, पैसे दे रखे हैं, पेट्रोल डलवा देना.
find out the root cause,
If process
fix
is
those.
continued, process error defects will increase. It will reach to rejection.
Exactly. So statistically, this is the inference. Move the mean closer to target and reduce the variation. Why am I saying move the mean? My CPK is unsatisfactory. My CPK is different from CP. Why am I saying reduce variation? My CP is unsatisfactory. So please remember these terminology and you should use the same language. These are statistical conclusions. But what exactly went wrong? Probably the team can discuss. Now, please tell me, all of you, for a process CP equal to 0.94, CPK equal to 0.33, and the process is not capable, what action is needed to improve the capability? Should I move the mean, or should I reduce the variation, or should I do both, or what's your point? Come on, all of you, tell me, what is the problem, statistically at least?
Sir,
Process
move the
is
mean
not.
and reduce variation, sir.
Very good. Move the mean and
What's
reduce variation. But what is reduce variation? What is moving the mean? Where is your mean? What is the target? Please brainstorm. If you brainstorm and then actively seek for information, and definitely you will identify the root cause, and then you will be able to take the right action. So capability of a process can be measured in terms of traditional yield, first pass yield, rolled throughput yield, as well as using the process capability indices. And the process capability indices can be used only when the characteristics under study is measurable. And in order to perform a CPCPK study, to avoid misleading conclusions, the process needs to be stable, free from outliers. All right. So these are the requirements, and the data must be collected in subgroup. And between every subgroup, there must be a time interval: 1 hour once, 2 hour once, 3 hour once, 4 hour once. If you violate any of these things, procedurally you are going wrong, and so you need to understand somehow your CPCPK will be misleading. It may not be as accurate as you expected, and those are the situations where your CPCPK will be perfectly all right, but some field failures and rejections will be continuously happening. So FPY, first pass yield, refers to the probability that your process can produce a good output without making any defects and without doing any rework. And this FPY is a familiar tool. TPMO stands for defects per million opportunity. This metric can be used for measuring the capability where output is measured in discrete units, countable units, good or bad, okay, not okay, like situation. In CP CPK study, CP compares the process width, which is 6 sigma, with specification width, which is USL minus LSL. CPK compares the process mean with the customer target in addition to comparing the spread with the specification spread. That's why CPK is superior compared to CP. However, no, CP still can be helpful to understand the scope that exists for improvement. If CPK is excellent, but still CP is higher than CPK, then you can definitely look for another level of improvement. For a critical process, CP-CPK should be more than 1.67. For a non-critical process, CP-CPK must be at least 1.33, right? And what is critical, what is not critical, you need to understand the situation. If there is a logic behind calling it critical, then it must be 1.67 condition must be fulfilled. So that's it. I think by now all of you are clear with the concept of CP-CPK. Is my understanding correct?
Yes.
Just in a very short way, I'll give one example. A restaurant manager, a five-star restaurant manager, they were, no, he was, the restaurant was having several branches, 35 branches, and he is responsible for customer satisfaction and the dining section. Okay, there were frequent complaints from the customer saying that the food is not served at an appropriate temperature. Do you understand the situation? There are customer complaints, and what the customers are telling, food is not served at appropriate temperature. Some people are saying no, food is served too hot. Some people are saying food is served too cold. And so the restaurant manager or the head, he understood food must be served at the appropriate temperature, and that appropriate temperature is, let us say, 30 to 35 to 40 degrees Celsius. Okay, 35 to 40 degrees Celsius. That means what is upper spec? 40. What is lower spec? 35.
30.
That means the target should be center, 37.5. Now, and tell me, food temperature, is it measurable?
Yes.
Yes.
Measurable. But are you measuring?
No.
If you want to use CP-CPK, you have to make it measurable. And now that restaurant manager is very intelligent. He has, put some sensor, and somehow, every 15 minutes or every 30 minutes, he is collecting the temperature of the dishes, and the data is getting recorded in a computer. Now, sitting at the, what do you call, the control room, he will be able to understand whether all his restaurant are serving the food to the customer at the appropriate temperature during the dining time or not. He used the X bar R chart, he used the CP-CPK, and he, every time an X bar R chart is giving an out of control signal, he was calling to the particular restaurant and questioning them. Why a particular dish has been served at a very low temperature. Yeah. And that's how you could see in five-star hotels and all, they keep all the food warm by keeping a small heater or a kind of a flame under each dish, isn't it? But this is only just to help you understand that CP-CPK study can be used in any situation. Only thing is, you should be able to understand whether the characteristics of interest is measurable or not, isn't it? No matter whether you are working in restaurant, whether you are working in a big manufacturing company, car manufacturing company, or aeroplane manufacturing company, or you are working in a chemical manufacturing company, or you are working in a footwear manufacturing company, or you are working in a noodles manufacturing company, or you are working in a pharmaceutical company, healthcare, no problem. All that required is a measurable characteristics, right? Whether a particular treatment will cure a particular disease or not, whether the hospital bed changeover time, are we maintaining the, what do you call, the requirement of affecting the bed changeover within a particular time. And please note, whenever you do not have tolerance on both sides, suppose the tolerance becomes only one side, in such a case you only have to calculate CPK, you no need to calculate CP. But control chart is still applicable, but CPK alone will do, and CPK need not be used when the tolerance is one side. Minimum weight should be this much, or maximum weight should be this much, or the bed changeover should happen within 30 minutes, or the call resolution must be given within 30 minutes. See, call resolution time, loan processing time, turnaround time, cycle time, lead time, anything that is measurable, height, weight, all of this. No, in all those scenarios, we can do a CPCPK study. Clear, all of you? Have you understood CPCPK? Shall we stop here for the break?
Yes, sir.
Are you
Yes.
confident, all of you?
Yes.
Yes, sir. Confident.
Very good. You can even do manually, or you can use Minitab. And please, all of you note, there is one another beautiful shortcut available. Nowadays, plenty of AI tools are available. You should only know the correct terminology and just copy the data, just paste it and give the proper prompt. Calculate CPCPK for the given data. That's all. And your manual calculation steps will be performed by the AI, and then the result will be available, but you are still responsible for the accuracy of calculation. You need to cross verify. I think that much you all can do easily, isn't it?
Yes.
Yes, sir.
Okay. And okay, I think I simply assume all of you, participated actively, because this is a very, very important topic, for all of you. In manufacturing industry, you might be discussing about CPCPK very frequently in all your meetings, but in
Sir,
other
any
areas,
specific example you can share for this one-side process for CP is sufficient.
okay. Okay, I will share it. Not now because it's your break time. I'll note this and I'll definitely discuss one-sided. But the thing, say for example, the particular call resolution, complaint resolution must happen within 4 hours of time. Whether so many complaints are coming, but the management prefers the complaints to be resolved within 4 hours. That means upper specification is 240 minutes. Lower specification doesn't exist. Yes or no? Lower specification doesn't exist. You can even close the complaint in 0 hour also. So upper spec is the critical here.
The Instamart supply also, they are saying half an hour, within half an hour.
Yeah, exactly. They are making a commitment. Banks are telling, your loan will be approved in just 2 hours, 40 minutes and all that. So these are all one-sided spec only. Only if that side you go beyond, it becomes a failure. The other side, it's not a failure. We will also do all the max maybe in the next time when we meet. Okay?
Yes, sir. Yes, sir.
Okay, thank you very much. Good participation as usual. We'll meet after the tea. So sharp
Thank you,
15
sir.
minutes.
Thank you.
Yeah, please.
Okay, guys. So all of you are back, right? From the break.
Yeah.
Okay. So we are going to see this tool called failure mode and effect analysis. This is a very critical tool. It is generally used. Okay, we will see this.
What is it?
So this tool is generally used in the improve phase. What we are doing in the improve phase, guys? Anybody having an idea? What we are doing in the improve phase?
Yeah. Improve phase is the solution. Generate the solution and implement the solution, pilot and successful implementation and documentation and the benefits.
So in the improve phase, actually, we are trying to generate the solution first, then evaluate the solution, select the solution, then implement the solution on trial basis. Very good. Okay, but in the evaluation phase, okay, we need a tool to evaluate the solution. We need a tool to evaluate the solution. Why you need to evaluate the solution? Because we need to find out what is the strength, what is the weakness, or what are the failures that could occur in the solution. What are the failures that could occur in the solution? Why we need to find out? Because all solution will have its own limitations, will have its own strength, will have the failures which can occur in, see, all solutions will have some side limitations, merits or demerits or lower sides. We need to find that out, and we have to ensure that particular weakness or that particular failure must not
A
affect the
selected
solution while
solution, a selected solution may work for now. In future, it may not work.
yeah. So we have to ensure that it doesn't affect the solution does not work. See, the solution has to be sustained for a longer period of time. For that, you need to know what is the weakness that is present in the solution. That is what we are trying to do. So we are trying to implement a solution which failure is already identified and the corrections for the failures are implemented. Okay, for example, let me say, during the COVID period, all schools, colleges, and educational institutions, training institutions were closed. Okay, so what was the only option available at the time for running the schools, colleges, and educational
Online
and training?
classes.
Okay, what are the failures that will generally occur in the online training programs?
Internet
Internet
connection.
failure. Yes, okay.
Power failure.
Yes, power failure.
Distraction for the people attending classes.
Yes, distraction. Yes.
Availability of digital devices like cell phones with all the students.
Yes, there is a possibility that some of the people might not have this digital devices, right? Electronic gadgets. So that might also affect the solution. Yes, then. And anything else?
Network issue.
Network issue, which has been already said. Yes.
Laptop skills on the part of students to participate on online and understanding the technical skill.
Sorry, unavailability of electronic gadgets. That is what you are saying, right?
Yeah.
Yeah. Then
limitations of two-way interaction.
Limitations of, yes, obviously I am not able to see where you are and what are you speaking, right? I am just hearing your voice and sometimes I'm seeing you in the videos. So obviously the clear interaction is missing. Face-to-face interaction is missing. Then anything else? That's it. Guys,
The same
software, right?
Yeah, the same thing which we are in the online class, then the same setup was implemented in the COVID time. This is the same scenario, either the work from home or online. This is the same example.
Yeah, same scenario. But what are the fail? The solution was quite successful. That is why we are using it even after the COVID period was over, right? So sometimes you need software. What is the software you need to have to interact with me? Zoom. Sometimes, yes, sometimes audio problems may occur. You may not be able to hear. Sometimes I may not be able to hear. That may also a failure. Sometimes you may not be able to see what I'm displaying in the screen. So sometimes you may not be having the Zoom software. Sometimes your audio controls may not be working properly. So you might have some disturbance in listening. You might not be able to see what I'm displaying. So many kinds of this kind of failures may impact the effectiveness of the solution. Similarly, for example, even a small spelling mistake. See, for example, see, here there is a word called failure mode. Instead of mode, if I have typed as failure made, FMAD, that is also considered as a failure. Even a spelling mistake in any one of the sentence, in any one of the word, is also considered as a failure. So in FMEA, we are trying to find out all possible failures. What I'm saying, please listen. We are trying to find out all possible failures that could occur in the solution. We are trying to find out in advance. We are trying to find out from historical records. We are trying to find out from previous data, and we are trying to find out by analyzing with the experts and consultants. So we are trying to find out all possible failure modes that could occur. Guys, do you got it? So that is the important thing which we have to do. Okay. So before going into failure mode analysis, let me give you some idea about this terminologies. So you know what is FMEA, failure mode and effect analysis. Then RPN, this is an important number. This is called the risk priority number. Then AP is called the action priority. This AAG and VDA are associations which are responsible for upgrading and improvising this FMEA regularly. So what you must remember is this FMEA, RPN, and AP, action priority. Okay. So as I said earlier, this FMEA is an analytical methodology. What do you mean by methodology? A step-by-step systematic procedure. Okay. So a step-by-step systematic procedure which helps you to identify the failures. So what is the first step in FMEA? You have to identify the failures. So just now we did, right? When I asked about the solution of online failure mode, you said, sir, internet failure, charge in the gadgets, unavailability of gadgets, and software unavailability, audio, video, and all these things can affect the particular solution. So our first job is to identify all possible failure modes. What is the first step? Identify all possible failure modes. Okay, now I am going to ask a question. Yes, guys, please listen. What severity rank will you give for an internet failure, and what severity rank will you give for a spelling mistake, which I mentioned earlier?
Highest
Let
rank
us say
for internet.
1 is the least and 10 is the highest. What will you give?
10 for internet, 1 for spelling mistake.
1 for spelling mistake. Why did you do so? Because you know the impact that particular internet failure can have on the solution.
It is a functional failure. It is a functional failure.
Functional operational failure. Pure functional operational failure. But regarding the spelling mistake, some of you might having a doubt, sir, what is this? Instead of mode, you have typed as pay. Okay, then I will say, yes, sorry, gentlemen, I will correct it. Simple, problem over. So the distraction, the disruption of the process when it comes to a spelling mistake is very less. But when it comes to an internet failure, the distraction, the disruption of on the process is high. The impact is high. So that is why we gave high, you gave a high score, severity score for the internet failure, and low severity score for the spelling mistake. Okay, so now you have quantified the failure. That's it. First, you have identified the failure. Now you have quantified the failure. What is quantification? Converting the failure, giving the failure a numerical value so that we are able to understand the impact of the failure on the solution. Got it, guys? First, you identified the solution, then you quantified it. Quantifying means converting the failure into a numerical value so that we are able to understand the impact of the failure on the process, impact of the failure on the solution. So by giving 10 for internet failure, you are able to understand that internet failure is having a high impact on the solution. It entirely disrupts the process. It entirely disrupts the solution. Okay, so we have completed 2 steps, identified and quantified. After that, you have to prioritize. Okay, now, for example, let us say we have identified some 25 failures that could happen in the solution. How many failures that could happen in the solution? We have identified 25 failures. Okay, so what we are doing is we are providing numerical values to all the failures. That is called quantification. Okay, so earlier it was a qualitative data. Now we have converted that into quantitative data by providing numerical values. Okay, once you provide the numerical values, you are able to arrange them in the descending order. The failures which has the highest numerical value, highest severity rank, will be occupying the topmost position. So we are able to identify which failure is important, which failure must be given priority. We are able to
Pareto also, sir. Pareto.
No. Pareto is used for identifying which project or which cause is having high impact on the particular project or problem. Okay, but here it is purely identifying failures. We are trying to identify the failures, and it is a 4-step process. Pareto is not like so. Pareto is just plotting the data. But
no,
here,
for prioritizing.
Why you are going for separately Pareto? You can just list out the numbers, and the numbers will give you idea. For example, there are nearly how many participants in the class? 35 participants. I conduct a test. Okay, and I gave marks to everybody. Now, who will be getting the first rank? The one who got the highest mark, right? Very simple. Why to use Pareto to find that? There is no need. See, you want use, but there is no necessity for that, because by looking at the numbers itself, you are able to find out this is the topmost failure, because its number is its numerical value. Its RPN is very high. Why you need to use Pareto? It is an unnecessary waste of time only. So you just see the number and you prioritize. See, for example, when there are 35 participants, one participant got 95. So what he is the highest of most highest, he is the one with the highest performance. So I will give him rank 1. Why I have to use Pareto? Got it?
Okay. Yes.
Okay, so there is no need for Pareto. Just you are based on the number, you are arranging that in the descending order. That is highest value on the top, next in the same manner. Okay, now you have identified the failures, you have quantified the failures, you have prioritized the failures. Now it is time to evaluate what kind of impact it will have on the solution. What kind of impact? Okay, and after that, you have to recommend certain corrective actions to reduce the impact of the solution. Okay, this is what we are going to do in FMEA. We will see it with an example, so no need to worry. So as I said earlier, it helps you to highlight the weakness. Okay, the downside, okay, then the affirmative side of the current solution. Okay, so we are trying to find out the weakness that is present in the solution so that it doesn't compromise the solution when it was implemented. Then, as I said earlier, we are trying to prioritize the potential defects, the defects which can cause impact, which can have impact in the failure which can have impact in the solution are going to be arranged in the top list. So we are prioritizing the potential defects, potential failures. And after that, we will recommend corrective actions for the failures. Okay. See, gentlemen, remember this FMEA was not developed by any automobile industry, but it was regularly upgraded and utilized in many automobile industries. But it was developed by NASA in the 1960s. Okay, to avoid failure of the satellite launch programs. Later onwards, it moved from NASA to US military, where they are manufacturing these weapons. Okay, then after that, it became a standard in the military weapons manufacturing. It was mentioned as military standard 1629. So this is how this FMEA came and it was being used effectively. And after that, from the US military, it moved into the automobile industry. And from the automobile industry, it was being used and spread throughout all industries. Nowadays, FMEA is very crucial and critical tool, which we have to use it. Without FMEA, many companies are not going to give you orders for the customer. Okay. So this is how FMEA came into this industries. Okay, now we must be aware that FMEA has two categories. One is process FMEA and one is design FMEA. When to use process FMEA? When you are going to use this FMEA for a process which is already existing, which is in usage, okay, which is available, then it is process FMEA. That is, if you are going to use this FMEA for a process or a product or a service or a system which is already available, which is already in operation, this is process FMEA. Then what about the design FMEA? If you are going to use this FMEA for any process or product which is under development, generally we can say it as new product development, new process development, new service creation. In this area, if you want to use this FMEA, it can be termed as designed FMEA. Got it, guys? What is the design FMEA and what is process FMEA? And we are more concerned about this process FMEA because we are just trying to implement the solution in our process only. So in a process which is already existing, which is already having problem. Okay, so we are always bothered about the process FMEA currently. Okay, already I explained what is a failure mode, the possible ways a system can fail. Guys, remember, when the product or process or system or service, if it is simple, the failure modes present also will be very simple. If it is complex, then the failure modes present will be more complex. Okay, for example, I am going to ask you a question. See, what are the possible failure modes that could occur in a home fire alarm? Guys, what are the possible failure modes that could occur in a home fire alarm?
There can be no connection, power connection in alarm.
Okay, no power availability. Yes, then
Sensor may be blocked by dust particles.
yes, sensor may not be working properly. Yes, very good. Then that's it.
Device is working, but sound buzzer is having a challenge.
Yeah, fail to create alarm. Sound may not be generated, so we may not be able to know that the sensor is activated or working. Okay, sound may not be coming from the sensor. Alarm sound may
Calibration
not
may
be
be
coming.
out of date.
Yes, suppose if the calibration or the sensors or the instrument which is present inside may not be working properly.
If
Because of
light
outage.
signal is there, means if light indication is there along with buzzer, then there is a possibility that light may not come. Or
Yeah,
if buzzer
suppose.
fails, only through light we can identify.
Okay, so as you said, lot of simple problems may occur. That is what we call as faulty wiring inside the printed circuit board or any board which is present. And if light is present, if the light is not, if the light has light fuse has gone, then obviously it may not work. So detectors, defective alarm. So the home fire alarm is a simple component, guys. So we are able to identify the failure that could happen in a home fire alarm. Then imagine about a aircraft. How many systems are there? Many complex systems, right? Even though there are so many systems in an aircraft, we cannot neglect or avoid any of the systems. We have to carry out this FMEA for every system, for every process that is happening in this. What will happen if you are not doing the FMEA properly, guys? What will happen?
A particular system will fail.
Yes, possibly, very good. Possibly the system may fail, and obviously
Chance
that
for
may
a
lead to
catastrophic
accidents.
failure.
Yeah,
For
obviously
example,
there is
in
a chance
landing
of
gear,
failure. There is an explosion.
if
Yeah, in landing gear, in propulsion, in aviation, in supply, communication, ice protection, environmental controls, many critical systems are there. There is a power plant also inside, which will ensure that the power is supplied throughout the aircraft. Any of the system fails, then obviously that will be a disaster for the passengers inside. So, whether the system is simple or complex, it is our foremost duty to do the FMEA so that we can identify the failure modes and we can prevent that failure from hampering our solution. Okay, whether it is a simple solution or a complex solution, it doesn't matter. So we have to do it irrespective of it. Okay, now we are going to see how these failures can be prioritized. Generally, it is prioritized by a number
How
called
frequency we
RPNs.
should prepare this FMEA?
Sorry?
How frequency that we should prepare this or refresh this FMEA?
You are asking what is the frequency we have to use is FMEA. That is whenever you are going to implement a solution, you have to use the FMEA. For example, you might have done some piloting of the solution. So before going for piloting, you have to use the FMEA. And after, and if you have made some corrective actions in the solution, then again you have to do the FMEA. See, we have to do the FMEA until you are sure that the failure which is present in the particular solution is not going to affect the solution heavily. FMEA and recommend corrective actions, implement corrective actions, do the FMEA again and again. Our objective is to find the potential fail the solution which we are going to implement. Got it?
Thank you.
So this priority number is a example. You are going for a tour with your family members. All in-laws, father-in-law, mother-in-law, brother-in-law, sister-in-law, daughter-in-law, everybody is there. Imagine. Okay, so you are driving in a huge car. So all of a sudden, the car failed. The reason for the failure is no fuel. The reason for the failure is no fuel. Okay, what kind of severity rank will, because there is no petrol fuel park in the vicinity of the next 50 kilometers. So obviously it is very difficult to get petrol or diesel. Okay, now
Severity
the
10.
car severity 10.
10.
Severity is high 10. Okay, now how many times has it occurred in your life, or how many times will it occur generally?
Very minimum.
2 or 3.
One or two times.
Saranan,
Because
please
we will
mute yourself.
monitor regularly while going for long drive, sir.
Very good. Mohammed Mazur said it correctly. See, when you are going for a long drive, you will check and monitor. So, but Mazur, my question is, how many times has it occurred?
One or
Rare
two
or
times. After
Very
that,
rare.
we should
very
target
rare,
on
right?
this.
Because of
Very,
the
very
indicator
rare.
availability, it is very rare.
Yes, yes, yes. Balasubramanian is correct. Why it occurred very rarely? Because there was a deduction system in place. Guys, why it occurred rarely? Because there was a deduction system in place which informed you that this failure is going to occur, that the fuel is at very low level, so go and fill it. Nowadays in car, we have some more advanced indication system. It says only 10 kilometers to 0. So go and fill it. It gives a warning, right? So you have a certain deduction system which helps you to identify the failure even before it occurs. So what do? You prevent the failure from occurring. Guys, do you get it? Even though the no fuel failure is very severe, you give a severity rank of 10, it occurs very rarely. So we give a occurrence rank of 1. If it is occurring frequently, we give a occurrence rank of 10. But in this case, our failure is occurring very rarely. Why? Because we have a very good reduction system. The reduction system indicates you, informs you about the unavailability of the fuel in advance. Even before 50 kilometers, it says only 50 kilometers to 0. So you immediately go to a nearby fuel park and fill it. So the failure is avoided. Failure doesn't occur. So obviously, even though if you have a very high severe failure in your solution, if you had a very good deduction system in place, the chance of occurring of that particular solution will be very less. Guys, do you get it? Do you understand what I said
Yes,
now?
sir.
Okay.
Yes, sir.
So,
Right, sir. Understood.
so what is the important thing which we have to do when it comes to failures in solution? We have to develop a very good deduction system in place. For example, I have been in communication with many industries. One of the main automotive industries, they have implemented some wonderful safety devices. For example, when the machine was acting quickly, if any operator has put their hands in between, the machine will stop automatically. It detects. So the accident doesn't occur. It detects the foreign particular
Light
object.
curtain,
Like
they
it,
will put interlocks. Light curtain
yes,
interlocks.
yes. So obviously, what happens? The accident doesn't occur. So this kind of solution, okay, this kind of detection devices which can predict the failure in advance can reduce the occurrence of the failure, can reduce the occurrence, not the severity, can reduce the occurrence of the failure. Okay, guys. So these three factors are crucial for FMEA: severity, occurrence, and reduction. Okay. So how we can decide this severity, occurrence, and reduction? See, actually, this is the steps which you have to follow to do the FMEA. That is, it is going to help you to identify all. First, you need to identify all possible failure modes. Okay. Then you have to assign values, rank from 1 to 10 for severity, occurrence, and reduction. And after that, you have to multiply that three values. Okay, you have to multiply the three values: severity, occurrence, and reduction. That is termed as RPN. Then, based on the RPN, you have to arrange the values in the descending order from highest to lowest. Now, the failure which has the highest RPN, is given topmost priority for immediate corrective action. So implement corrective action, then do the FMEA once again for the solution and see whether the potential failure impact has reduced. Okay, so this is how you do the FMEA. Anybody having doubts in these steps in the FMEA?
One doubt.
Yeah, please go ahead.
In the case of detection, if it is easy to detect means the lower number you should give, or
So to clear your doubt, I am going to show you a slide. Okay, so here you can see. If you are certain, if you are very sure that you can detect the failure in advance, give a rank of 1. If you are quite unsure, if you are uncertain about when that failure is going to occur, as you don't have any detection system in place, you are going to give 10. If you are having a moderate capability of detecting the failure, give 4 or 5 or 6. Got it, Balasubramaniam?
good, understood.
Okay. Similarly, when it comes to severity, see, the stable will help you to do it easily. When it comes to failure, when it comes to severity, if the failure in the solution, if it is having no effect or least effect or negligible effect or minor effect, then you are going to give rank of 1 or 2. If it is having high potential effect intact, okay, hazardous, highly risky, hazardous, high risk with warning, high risk without warning, then in this case you go for a severity rank of 9 or 10. 9 or 10. Moderate means 5 or 6. Then similarly for occurrence, if the failures occurs frequently, regularly, 1 out of 2 times, then the percentage of defective is high, it is 50%. Then you have to go for higher ranks like 9 or 10. And if it occurs very rarely, very remotely, very in a low manner, that is 1 out of 15 lakh times, then you have to give 1, 2, or 3. Moderately, then 5, 6, 7. See, if the failure occurs very rarely, then the CPK value of a process will become 1.67. What does CPK value 1.67 indicate, guys?
The maximum value and good in process.
See, if a CPK value is more than 1.5 or 1.67, yes, very good. The process is highly stable and consistent. That means
capability and process. Yeah, consistent process and capability.
Yes, correct, absolutely correct. Reliability of the process is high. Stability of the process is high. That means the failure occurring in the process is very, very rare and highly remote.
Very rare.
So, based on these tables, you can give the rank for severity, occurrence, and detection. Okay, guys, do you got it?
Yes.
Okay, now we will see a small example. Let us take a critical step in the ATM operation. When it comes to ATM operation, ATM PIN authentication is one of the critical steps. So first we will try to find out what are the possible potential failure modes that could occur in the ATM PIN authentication. One is the unauthorized access. One is the unauthorized access. Another one is the authentication failure. What do you mean by unauthorized access? That is somebody
Another person is authorizing.
Yes, another person is trying to authorize using a PIN into your account. Okay,
Yes.
that is unauthorized access. So what kind of severity rank we may give for this kind of unauthorized access?
10.
Yes, 9 or 10, very high. Okay, then what about this authentication failure? When you go to the ATM,
forgot password.
Yes, when you go to
improper PIN code.
Yes, improper PIN, or sometimes the server may not be working because of power failure or internet outage, or because of some kind of server downtime or some kind of electronic issues. That is authentication failure. So when such authentication failure happens, there is no loss, but there is some kind of irritation on the part of the customer. Because you go to the ATM and put the card, the money is not coming. Instead of that, a message is coming. Server failed, server outage, internet unavailable, power unavailable. You are getting some messages. So what kind of severity rank will you give for this kind of failure, guys? It is moderate
10,
only.
2 to 3. Mild one.
It's mild one. You don't lost anything, but you are irritated. That's it. So you can give 2, 3, or 4. Okay, then let us come to the occurrence. What about the chance of occurrence of this kind of unauthorized access? How many times we have faced it in your life? Frequently or
Very
rarely
rare,
or not?
rare only.
Very rare only. Because nowadays we have improved our knowledge and awareness. Banks also spreading a lot of awareness about this kind of activities. So we are very aware when it comes to PIN number. So we don't expose it to anybody. We don't write it anywhere. We always keep on changing it. And so we keep it safely because of the awareness and the exposure developed by the banks. Okay, so normally it occurs very rarely. What about deduction system? See, if anybody is trying to put a ATM pin and immediately you are getting messages, well, you are trying to take account from your money from your account. Is it you? Suppose if the ATM pin, if you have inserted the ATM pin incorrectly, immediately you are getting a message. You have inserted a wrong pin. Please check whether it is you. If not, please block the card. This kind of advanced deduction process helps us to avoid this kind of unauthorized access. So we can give a moderate rank of 3 or 4. Okay, when it comes to authentication failure, what about the occurrence? It is moderate because whenever there is a power failure or heavy rains or server outage or internet failure, it happens. And the chances of detection also is very difficult because banks also doesn't know when this kind of server outage will occur. Sometimes when they are going for some server maintenance, they are able to identify it. But when it comes to emergency internet failure or power failure, banks are also not aware of it. So it is quite moderate. So we give a rank of 5 or 6. Okay, now let us calculate the RPN. How to calculate the RPN? 8 into 3 into 3. Multiply the severity occurrence reduction. 8 into 3, that is 8 into 3 means 24, 24 into 3, 72. Here 3 into 5, 15, 15 into 5, 72. Okay, now the question is for you. Which activity or which potential failure mode will you give high priority?
The one with highest RPN?
Yes, logically the one with the highest RPN. See, logically, the one with the highest RPN must be given importance. But we have to go for some analysis. What kind of analysis? That is, when two RPN values are close to each other. Here you can see the RPN values are having a difference of 10% only. In this case, you have to go and verify the severity rank. What is the severity rank for unauthorized access? It is 8. What is the severity rank for authentication failure? It is 3. So, based on the severity rank, you have to give priority to unauthorized access. You might ask a question, sir, then why always calculate RPN? Just look at the severity rank and give it. But we are going to look into the severity rank based on certain criteria, like when the RPN values are close to each other. Okay, suppose if you still have doubts, you can go for this kind of action priority table. What is this action priority table? The action priority table helps you to avoid this confusion. Okay, it simply decides based on the severity rank. See, for example, no need to calculate RPN here. You have to allocate ranks for all the 3 factors like severity, occurrence, and reduction. So here you can see if the RPN value is 9 to 10, most of the times it is given high priority. Even if the rank of the deduction is 2 to 4, we are least bothered. Even if the rank of the occurrence is 2 to 3, we are least bothered. We are always going to give high priority for a failure which is having a severity of 9 to 10. Then let us move to 78. In this case also, most of the times we are giving high priority. When it comes to 4 to 6 only, the priority becomes moderate, medium. When the severity is 2 to 3, priority becomes lower, least. So based on the severity, occurrence, and reduction ranking also, we can decide the action priority. So either you can go by RPN value or you can go by action priority. So this is how you can decide. If the RPN range is between 1 to 8, okay, it is a low risk failure. If it is above 250, it is a high risk critical risk failure. Immediate action is required. If it is in between 81 to 160, moderate. If it is in between 160 to 250, it is high risk. So based on this also, you can decide which failure has to be given immediate priority. Okay, for action priority also, I have a summarized table for you. If the severity index, if it falls between 7 to 10, always that particular failure must be given high priority. If the severity index, if it falls between 1 to 4, it is always low priority. If the severity index, if it falls between 5 to 6, most of the times it is medium priority. So if you have difficulty or if you have any confusion in choosing the failures based on RPN, you can simply go by action priority, which eliminates most of the confusion. Any questions, gentlemen? Yeah.
One doubt, sir.
Yeah.
This priority, choosing high, medium, low, it can vary with perception from a person to person.
No, it has to be done as a team. The team has to give the severity rank, occurrence rank, and reduction rank. No individual opinions or experience or expertise or hierarchy should play a major role. Always, actually, we have some table. We have a table, right? It's Muhammad Mazu. We have a table. This table, you check with this table. You check, for example, if the frequency of failure occurrence is matching with any of the number, you give the rank. If the severity, if a particular failure is affecting the process, based on this, we can give the rank. That also has to be decided as a team. Got it?
Yes, yes.
Okay. So now, once you have identified certain failure as a critical one, which is present in the solution, you go and implement a corrective action. What do you have to do, guys? We go and implement a corrective action. So after implementing the corrective action, there must be some change in the severity or occurrence or reduction. So that will reduce the RPN value or the action priority index. Okay. So after implementing the corrective action also, you have to do the FMEA once again. You have to do the FMEA once again to ensure that the RPN value or the action priority value has come down, has been brought down because of the corrective action. So this is all about FMEA. So this FMEA is a critical tool which helps you to identify, quantify, prioritize, and evaluate the risk. Why we have to do it? Because in order to find out the weakness that is present in the solution. How we do it? By bringing three factors: severity, occurrence, and reduction. How we calculate RPN? We multiplying the three factors. Based on the RPN value, we arrange the failures in the descending order. Okay. And suppose if you have any difficulty in choosing the failure based on the RPN, you go by action priority. Action priority helps you to choose the importance of the failure based on severity ranking. Severity ranking 7 to 10 must be always given high priority. So that is how we execute this FMEA. Any questions, gentlemen? Any questions? Okay, then I have some questions for you. What is the answer for the first question? What is RPN?
Risk priority number.
Risk priority number.
Yes, all of you are clear.
Any tool,
Yes,
sir?
B, risk priority number. Okay, what is the answer for the second question?
B, to analyze potential failure.
B, sir, B.
That's very good. B, potential failure modes and their effects. Okay, what is the answer for three? Question three.
Probability.
Probability.
Yes, probability is not a factor. Yes, C, answer C. Okay, what about four? Question four.
C, answer is C.
C, implement corrective.
Yes, C. Okay, so implement corrective action
to reduce severity.
Currents are improved reduction.
Answer is C.
40.
40.
40.
Okay. 40. Answer is C. Okay. According to what about the answer for 6? S1 indicate?
Very serious effect.
Serious.
Very serious effect, yeah. Severity, yeah, very serious effect, yeah.
Yes, 1 means very serious,
No, low.
No effect.
No. No
you
effects.
guys are you guys showed lot of urgency to answer. That is why you made a mistake. You have to see the answers, read the answers carefully, guys. In exam, you have to do it carefully. Yes, 1 means it is 1. That means no effect. Yes, 10 means very serious. Got it, guys?
Yes, yes.
Okay.
Okay. You have to be careful while reading the options. All options may look like
mild
answers.
effect. Yes.
Mild. No effect or
Yes,
mild
mild.
effect or negligible
No
effect.
effect or mild effect.
Okay,
I
what
just
about
want,
O1? Yeah.
can we
Mild
reduce
only.
severity? We
Not
can work
likely.
only on detection and occurrence, but can we work on severity? We cannot, I think.
Yes, most of the times we cannot work on severity. It is not possible to reduce the severity, right?
Correct.
Yes, the severity, higher severity is always severe. But you can improve the reduction and reduce the occurrence. That is the only thing which you can do. Very good, valid point. Okay, what about this question? O1 indicates?
It's like
Not likely.
Not
Very
likely.
good, very good. You people are very clever. You have read the answers carefully. Not likely. Yes, not likely. Okay, O10 means?
O10 is
Highly.
severe.
Highly likely.
Highly likely.
Highly likely.
Highly likely. Okay, okay, highly likely. Okay, what about the next question? If two failure modes have same RPN,
Option D.
can go by
Action.
you can go by A or B. Focus on high severity rating, or you can consider action priority. Okay, I believe all of you have understood it very clearly. Okay, so any doubts in FMEA?
No, sir.
Okay, now
But
we are
these
going
tools
to
can be used, no, sir.
Tools.
For measuring these, which tools can be used, sir?
FMEA itself is a tool. It is a critical tool to identify the failures that is present in the solution. Okay.
Yes, sir. Is there any like Excel format or like mini?
Oh, you are asking it. No, actually, there is no such tool. Actually, you can just there is no great calculation involved. Only S into O into D. That is the only calculation involved. You have to refer the table. You have to base on RPN value. You have to refer the table. That's it. There is no tool specifically involved. But we are going to see another interesting tool. That is control charts. Okay, we will see that. In another 15 minutes, we will see the control charts. Okay, what is the control chart? Where we are using this control chart? What is the use of the control chart? See, when it comes to improve phase, when it comes to control phase, some slide here. Okay. In the control phase, we are trying to implement certain control measures. What we are trying to do, guys? We are trying to implement certain control measures. So control charts is one of the important control measures. So what does a control chart do? See, we are using the FMEA in the improve phase. We are using this control chart in the control phase. The control chart is a very good tool to monitor the process after the solution was implemented. So we need to monitor the process. So in order to do that, you need the help of control charts. So what the control chart is being used for? It is used to monitor the stability of the process. What does stability means? Whether any abnormal variation is happening, whether any failures are happening. You want to identify that, you have to use a control chart. Next, it helps you to find out the readiness for improvement of the process. For example, if you are trying to improve your process by adding additional machineries or by recruiting new manpower or by increasing the capability or by adding new softwares, by adding new workstations, new servers, you are trying to improve the solutions by expanding lines or manpower. Then in order to find out the readiness of that, you can use the control charts. If the process is stable, you can study that with the help of the control charts. If only the process is stable, you should go for improvement. You have to go for expansion. You have to go for capital investment. Okay. And apart from that, it helps you to prove that your process has improved, that your process performance has improved. Okay. So this is the purpose of the control chart. Okay. So when it comes to control chart, please go ahead. This is also a question.
We use the control chart at measure phase also, no, sir?
Why? You can't use it in measure phase. In the measure phase, you are trying to find out you are trying to collect the data.
Yeah,
trying
data
to,
collection. Yeah.
data is
Data
being
collection.
collected, and that
Should
collected
be
data
corrected.
is used to calculate the process performance. But here, you have implemented the solution. You have implemented the solution, and you want to check whether the solution has really worked. How you can see it? By looking into the control chart graph. By looking in, see, but in the case of measure phase, already all your process performance index will be very low. Then why to go for a control chart? Your DPMO will be very high, your sigma level will be very low, your first pass will be low, your traditional yield will be very low, CPK value, CP value, everything will be low. Then why you have to use a control chart? Already your process performance index are showing low performance. Then why to use it? There's no need. But here, all your process performance indexes are very good because you have eliminated the problem. So you have implemented the solution. So you want to prove that your process performance has improved for next 30 days. Just draw a graph. The graph is okay. Then it means your process is performing well. In order to prove that to the top management, you can use the control charts. Okay. You will see it later. We will see the complete drawing of a control chart, then you will be able to understand. So in a control chart, you will have these two kind of causes. One is common cause, another one is special cause. One is common cause, another one is special cause. What is common cause? For example, you may take, how much time will you take to go from your office to home normally?
6 days. In
6 days. How much time will it take for you to go from office to home? How much time?
1 hour.
Maybe 30 minutes.
30 minutes. Okay. Plus or minus, let us say 25 to 35 minutes. Suppose if you are taking 60 minutes, whether it is normal or abnormal?
Abnormal.
Abnormal. It is
Suppose
the
if you
failure
are
of the CPK.
Suppose if you are driving, suppose if you are driving in 15 minutes, 1.5, that is normal or abnormal?
Abnormal.
This is also abnormal, sir.
Because you should not drive at 180,
Very
200.
fast. Yes.
Yeah.
Very risky. Okay, so this is common, this is abnormal. See, same thing.
Yeah.
Right? So last one is very, very abnormal. Nobody will accept it. Huh? Your family will not accept it.
Put absent.
Yes.
Put absent. Okay. So,
sir,
yeah.
In the control chart, we have to sustain the solution, implement and sustain the
Actually,
solution.
control phase is helping you to sustain the solution. How? By monitoring it regularly. See, for monitoring the control, by for monitoring the process only, you are having this control charts. See, it is like a camera. See, when there is somebody coming inside, you are immediately alerting the people, right? So, if any abnormality happens in the process, this control chart will give you an indication. Okay, so by seeing that, you are alerting your process people that something abnormal is happening. Let us wake up and check what is that. Okay, so don't worry. If you complete this topic now, you'll be able to clear all your doubts. You'll be get rid of all your doubts. So don't worry. So we have two causes which happens normally. One is common, another one is special cause or abnormal cause. Our job is to find out the special or abnormal cause which is present in the process, which is creating trouble to the new solution and the process. Okay. Now let us move into the control charts. No need for this, already we have seen this.
In control chart terminology, more than upper and lower specification limits, this abnormality.
Upper and lower control limits. Specification limit is given by the customer. Control limit is defined by the
UCL
process.
and LCL.
Yes, very good. UCL and LCL. So the control charts helps you to identify the stability of the process. How, if all the points from the sample which you collected, if it is within the control limits, upper and lower control limits, then the process is stable. Okay, control charts helps you to identify that. Okay, control charts helps you to identify that. If your process is stable, you can improve your process by statistical process improvement. Okay, that is, you can improve the sigma level from 3 to 4, from 4 to 5, from 5 to 6. Okay.
Okay.
So now, what are the different types of control charts available? We have nearly 7 types of charts. We have nearly 7 types of charts based on the type of data. Now, at this level, first we are going to see control charts for continuous data. That too, we are going to draw the control charts for continuous data or variable data with the subgroup size of 8 or less than 8. Okay. For subgroup size more than 8, we have to go for X bar S chart. For subgroup size less than 8, we have to go for X bar R chart. Okay, if the subgroup size, if the sample size is 1, it is IMR chart. If the sample size is 8 or less than 8, it is X bar R chart. That is average range chart. If the sample size is more than 8, it is average and standard deviation. S means standard deviation. S means standard deviation. This one. This one means average and range. This one is for a sample, single sample. Okay, if the data is attribute data, that is countable data, then we are having 4 type of charts: C, U, N, P, and P. We are not going to bother about these things. We are just going to look into this chart, X bar R chart.
Measurement variable data.
Yes, measurable data or variable data, continuous data. So when it comes to X bar R chart, okay, you must know that the sample size or the subgroup size must be always 8 or less than 8. 8 or less than 8. Okay. So in the meantime, some calculation will be going on. What kind of calculations? That is, you have to calculate the center line, that is X double bar, and you have to calculate the mean of ranges and upper control limit, lower control limit for both the X bar and R chart. Actually, if I say X bar R chart, that means you have to draw 2 control charts. One is R chart, another one is X bar chart. If I say X bar R chart, guys, how many charts you have to draw? 2. One is X bar, another one is R chart. Okay, first, which chart you have to draw? You have to draw the R chart. Draw the R chart. If R chart itself is not good, if the data which you collected from the process, if it fluctuates above and below the control limits in the R chart, then no need to draw the X bar chart, because that itself is an indication that the process is unstable. If the R chart is clear, if with all the points in the R chart, if it is within the control limits, then you have to go for the X bar chart. Okay, we will manually first draw a X bar R chart. Then we will, this is how a X bar R chart will look like. This is the X bar chart. This is the X bar chart. Here you can see this is X double bar. Okay. Upper control limit, lower control limit. Okay, this is a sample chart. Okay, how to calculate this, draw this X bar chart? We will see a small example manually. For example, I have collected the data from a company. That is, I have collected the data to identify the performance of 4 different work groups. Okay, each work group is working in a different shift. One work group is working in first shift, second work group is doing in second, third is in third shift, fourth work group in fourth shift. So I am collecting 5 samples per shift. How many samples I am collecting, guys? 5. So for every group, every day I am collecting 5 samples. So how many samples I am collecting per day?
20.
25.
No, 5.
4 into 20, only 4 groups, right?
4. Okay, 20.
So I do it for 5 days. I continue it for 5 days. So how many samples I get? I get 100 samples total.
100.
Total number of samples is 100. But what is the sample size I am collecting?
5.
5. Okay. Now I am going to give you steps. These are the steps. Okay. First, you must decide the sampling plan. What is the sampling plan? That is the sample size. Here the sample size is 5. So I am collecting 5 samples per shift, and I am doing that
4 shifts
for
per day.
4 shifts per day, and I am collecting 20 samples for 5 days. 20 samples for 5 days, so 100 samples I have. Okay. So always you have to decide the type of chart based on the sample size. This is the sample size or the subgroup size. So what is the sample size here? It is 5. So what is the chart you have to use? You have to use X bar R chart. You have to use X bar R chart only. If it is more than 8, for example, the sample size is 9, you have to use X bar S chart. That is X bar standard deviation. Here the sample size is 5, less than 8. So you will use X bar R chart. Okay. Now, first you have to calculate X bar. What does X bar mean? That is average. Then you have to calculate R, range. After that, you have to calculate X double bar. Then you have to calculate the R bar. Okay. Okay, let us do it. This is the data which I have collected from the company. Now, how to calculate X bar? Add all this 5 datas. Divided by 5. Yes. Then you get X bar. How to calculate range? Range is the difference between the highest and lowest value in that sample. Or how will you calculate range? Yes, minimum. What is the minimum value? What is the minimum value, guys? The minimum value is 590. What is the maximum value? 601.6. If you subtract it, the range is 3.6. Likewise, you have to calculate for all the 20 samples. X bar and R. You got it, right? X bar and R. Now, what you have to do is, you have to add all this 20 X bar and divide it by 20. Then you got X double bar. That is average of averages. X bar is the average of every sample, and X double bar is the average of all X bars. Guys, do you get this step? Any questions? Any doubts, please raise it.
No, sir.
Okay. Now you calculate range for all. Yeah.
Sir, sir, I have one doubt. Here
Yeah,
it is showing all the average is around 600. Okay. Here, what if I have something different sizes of the data, which means one shift produces 100 and another shift produces 200 and another shift produces 300, like that.
So you have to change the sample size accordingly. Depending upon the population, you have to increase the sample sizes. When you increase the sample sizes, you may have to go for a different chart. That is X bar S chart. Got it?
Okay, okay, thank you.
When the number of samples increases from shift to shift, you have to increase the number. When the number of components which you manufacture increases or decreases, you have to vary the samples accordingly. If more components are manufactured, increase the samples. If less is manufactured, reduce the number of samples. Right, Rajesh?
Okay, sir. Okay, sir. Thank you.
Okay. Okay. Likewise, you calculate the X bar, then add all the X bar divided by 20, then X double bar. Add all the R and divide it by 20, you got R bar. That is average of ranges. Okay. Okay, now this is how a R bar chart, R chart is going to look like. So in order to calculate the R, in order to draw the R range chart, you have to calculate upper and lower control limits. How to calculate this upper and lower control limits? There is a standard formula. What is the standard formula? D4 into R bar. You already calculated R bar. What is D4? D4 is a constant. It is a universal constant which is available in internet, which is available in all process. Okay, so depending upon the sample size, this D4 value will vary. Okay, so if the sample size is 6, the D4 value will be different. If the sample size is 3, the D4 value will be different. So there is a table, constant table, which you can take it from internet. If you search R range chart constants, you will get it immediately. Okay, so for D4, for this chart, you are having a sample size of 5, so the D4 value is 2.114. Similarly, for calculating the lower control limit of R range chart, you have a formula of D3 into R bar. What is the D3 value for sample 5? It is 0. Okay, So using this, you can calculate the upper control limit and lower control limit for the range chart. Guys, do you get it? Okay. Now you have the range values, you have the R bar value, you have the upper control limit value, you have the lower control limit. Okay. Now let us draw the R bar, upper control limit, lower control limit. Now, what is the job? You have to plot all these values. What is the first value here?
3.6.
3.6, 2.8, 4, 2.8. You plot all the points.
Okay.
Correct it? Whether anything is above or below the control limits?
No.
So obviously the process looks stable. As per the range chart, the process looks stable. So now you can go ahead and draw the X bar chart. If the process, if the range chart itself is unstable, if the data goes above or below the control limit, then no need to draw the X bar chart. Guys, do you got this? Are we clear?
Yes, sir.
Are we
Clear.
clear? So
Yes, very clear.
if any data goes above or below the control limit in the range chart, no need to go to the X bar chart. No need to draw the X bar chart. Stop there itself, because that itself is enough that the process is out of control. Okay. So first you have to complete the X bar chart. Okay. Now we have to go for the R bar chart. Sorry. So first we have completed the range chart. Now we have to go for the X bar chart. How to draw the X bar chart? Same process. You have to calculate the upper and lower control limit. Already you have calculated the X double bar. Okay, we have calculated the X double bar. We have to calculate the upper and lower control limit. So for X bar chart also, we have a formula. What is the formula for calculating the upper control limit? X double bar plus A2 into R bar. This is a standard formula available. Common standard formula universally available for all people. You can search it and find it, or you can download it. For lower control limit, X double bar into A2 into R bar. What is this A2? A2 is a constant. Okay. For the particular sample size, of 5, A2 is 0.577. Okay. This is also available in the internet. This is the common value only. Okay. So you multiply, substitute this X double bar plus A2 0.577 into R bar. R bar value is 2.72. For lower control limit, X double bar minus A2 into R bar. So substitute this and calculate the upper and lower control limits. Let us draw the chart. This is the central line, that is X double bar, upper control limit, lower control limit. Now plot all these X bar values. What is the first value? 600.36.
100.3.
Yes, plot all the values. Got it? Any fluctuations out of control situation?
Yeah,
Yes,
lower
sir.
control limit. Exceeds the lower control limit.
Yes. Yes, on 8th shift. On the 8th shift, that is second.
Ninth shift.
No, 8th. Actually, 8. This is 1. This is 1.
Process is not stable, sir.
Process is unstable. Because some particular data on the 8th shift goes beyond the control limit, below the control limit. First, you have to investigate the reason. Check the operator, check the data collection process, procedure, MSA,
Because
everything.
it is a random occurrence. It is not recurring continuously.
Yes. If it is a random occurrence, you check it. And if you are able to identify the cause, well and good, you rectify it. But if it is occurring repeatedly again and again in the coming days, and if you are unable to find the cause, that is a Six Sigma project, guys. What is it then? It is a Six Sigma project because the cause is unknown. So you have to start from define, measure, analyze, improve, and control. Because you have to find out the problem, reason for the problem, reason for this abnormal cause. Because this abnormal cause may be 1 or 2 random occurrence. Later onwards, it may spread like 10, 20. Obviously, a process will be. So now we are able to monitor that some kind of random abnormal causes are occurring in our process. So we have to ensure that it doesn't occur in the future. Because if it occurs regularly in the future, it will affect the stability of the process. It will increase the number of defects. Got it, guys?
Yes, sir.
This is how you have to use the control charts. Okay, now we are going, see, if you have to do this manual calculation, it is going to take a lot of time. Let us do it in fraction of seconds. How? with the help of Minitab. Guys, listen, we are going to, how many of you have installed Minitab?
Yes, sir. It's not.
So please open the Minitab. I also will open simultaneously. So I am going to share the screen with the Minitab. Okay, guys, that is my Minitab. It's opening. Have we got this page, guys? Minitab.
Yes.
All of you, please open the Minitab. Okay, you have received a Excel sheet which says as Sigma level calculator, right? Guys,
Yes,
do
sir.
you have, yes, do you have it? Okay, simple, we can do like this. Okay, now please click on file. Please click on file. Please click on open worksheet. In that, at the bottom, you have an option, look in Minitab sample data folder. Search for camshaft. Here it is. Guys, do you got it?
Yes.
Click on camshaft MTW. Click on OK. Guys, do we got it? Anybody having doubts, or you want me to repeat it?
Sir, 1 minute, sir. Repeat it, sir.
Okay. Then we will.
Go to file.
Okay,
Still
file. Open worksheet. At the bottom, you have an option called look in Minitab sample data folder.
Sir, you have to open the project.
Yes, you have to open that particular Minitab file. Click on cam. You have this camshaft MTW.
Yes.
Okay, click on yes, then it will be displayed.
Yes, sir.
All of you got it?
Yes, sir.
But that in that file only we have to work, sir. Sample data, Minitab Excel file only.
Yeah. Hey, we are going to draw this one. We draw manually. We draw the control chart for a manual system, right? For a system manually.
Sir, you have to go to file, sir. File.
Let's go to file, open worksheet. Okay, in that you have to search for camshaft. Camshaft MTW.
Open worksheet, then
Camshaft.
It is not coming. Custom
Then,
system.
then at the bottom you have to look in Minitab. Have you installed Minitab? Then at the bottom here, just look in my. Actually, look in the cursor. Please look where I am circling. At the bottom, you have an option like this. At the bottom, do you look in Minitab sample data folder? Do you have an option like this? At the bottom of the window. Guys, do you get this?
Yes, sir.
Okay, now we have opened the Minitab file. Now click on statistics, the top STAT. Then control charts. Then control charts for subgroups. Then X bar R. Click on that. You will get a window opening like this, small window. Click on follow my cursor. Click here. So then all the three data will be displayed. So what is actually the observed data, the length? So double click on that. Length will be displayed. What is the subgroup size or the sample size which we have chosen? Do you remember the subgroup size which we have chosen for that example?
4.
Actually, we are collecting how many samples per shift?
5.
5. We are collecting 4 shifts. Samples for 4 shifts. But in
20.
every shift, we are collecting 5.
5.
So click on OK. Yes, that's it. That's it. You got it. Very simple. Anybody want me to repeat it?
No.
Anybody want me to repeat
From
it?
start, control chart.
Stat, control charts, variable charts for subgroups, X bar R chart. Click on that. Okay, we will do it. No problem. Click on that. You click on this box and you will get all the data on the left hand side. Click on length. Then enter the subgroup size 5. Then click on OK. Stat. Okay, let me repeat it. Statistics, control charts, variable charts for subgroups, then X bar R chart. Then you will be getting a window like this. So click on this, you will get all the data coming here on the left hand side window. Then length is an important parameter here. Okay, so click on length. It will be displayed here. Now, what is the sample size which we have collected per shift? 5 samples. Click on OK. Then you will get this graph. Same graph, right? So in the X bar R chart, you are getting some data out of it. So verify it, investigate it.
Sir, after clicking that length, it is not getting displayed in that window.
See, statistics, control charts. Okay, I will repeat it once again. Statistics, control charts, X bar R.
Yeah, I have typed it. Now it's coming.
You click on that. That's it.
Yeah, after clicking, it is not coming. I have typed it.
You can't type it. You should type it. See, actually, okay, I will close it. So I have opened the file. Now I'm going to start fresh. Statistics, control charts. Control charts are variable X bar R chart. This is what I will get. Do you get like this?
No. That window is blank, and even if we click on length, that is not displayed here.
You have to click it here first. Then you have to click it. Actually, whether the data is displayed here on your worksheet, do you have this data displayed here? Do you have this data displayed here?
Chart, sir.
Yes. You should the data must be displayed here. For that, click on open worksheet, then click on camshaft. Then only the data will be displayed here. Camshaft MTW. You have to display the data here first. The data which is displayed here only will be seen in the window which we are opening later. First, it should be displayed here. You have to import it through this option, open worksheet. Okay, in that type C. If you are not seeing this file, click on look in this Minitab folder. Please follow the cursor. Look in the Minitab folder. Then type C, then you will get camshaft. You will open once again, yes. After that, from this data only, that window is pulling the data. So statistics, control charts, subgroups, X bar R chart. Okay, so click on length 5, then click on OK. Yes, how many of you have done this?
Yes, sir.
I have done this.
Okay.
Followed the same process, but still that length is not coming in that small window.
So actually, but the thing is, whether you are getting this data in that Excel worksheet.
There. Yes.
Yes, sir, I got this data, but after clicking that length, in that box, length was not getting displayed. So I have typed it. Now it has taken and got the chart.
Okay, display your screen. We will see how you are doing it. Display your screen. I am allowing you to share this.
Actually, I am using tab for this audio and another system for this Minitab.
Oh, then it is difficult.
I will share. Yeah.
Okay, try to share. You will see what error is coming. You are doing in the worksheet. You are not doing in the Minitab.
It is Minitab.
Okay, click on start. Click on. Okay, click on start.
Camshaft MTV MW.
Okay, click.
Yeah.
Okay, click on shaft. Okay, statistics.
Yes.
Statistics.
Control charts. Then
Control chart.
X bar chart.
Variable chart.
If I click
chart.
here, all these are.
Click on length. Click on length.
Yes.
Double click.
Okay, double click. Okay, I was.
Then enter subgroup size. Subgroup size is 5. 5. Click OK.
Okay. Yeah. Thank
That's
you.
it.
Yeah. Thank you.
Okay, you can stop sharing.
It has to be double click.
Yeah, that's it.
Yeah,
if single click is not working, do a double click. That's it.
Yeah. Okay.
Same mistake, sir. I have clicked only one time.
Oh, okay. Sometimes it may work, sometimes it may not.
That working file could be that Minitab Excel only, right, sir?
See, actually, if you don't have this Minitab file, you can copy from any file. You can copy from any file. Even I can copy from the Excel sheet. See, for example, I can copy the Excel file. I can paste it here. I can paste it here. You can copy from Word, you can copy from Excel and paste it, and you can generate the control charts.
Okay, understood.
Okay, are we clear, guys? So this is how you draw the control charts manually as well as using Minitab. Using Minitab, you can do it just in fraction of seconds. So easy. So using control charts, we are able to monitor the process stability and whether it is deviating from the process.
Excel also, no, sir?
Sorry?
Same thing can be done in Excel also.
Yes, you can do it in Excel also, but it is complicated. Why make it complicated when you have Minitab? It's just very simple and easy. Okay, guys?
Okay, thank you.
Okay, that's it. End of the session. So any doubts?